Hello, hello. Test 1, 2, 3. Can you all say something?
Hey, 1, 2, 3, test.
Hello.
Test, test.
Okay, I'm gonna modify the audio a bit. Hello. You all hyped or not? We are very much hyped. Hello.
Extremely
Mushik, you wanna take it away?
Sure. So, hi everyone. Welcome. Wait, actually, you should call me Václav, right? We agreed that the other Vasek will be Vasek. So we have a. Okay, let's start from the beginning. Hey everyone, welcome to the Polylog 100,000 subscribers anniversary livestream. When we hit this milestone, or when we knew that we were going to hit it a few months ago, we were thinking about what's a good way to celebrate. And the live stream is something that we've never done. So we thought, let's give it a shot. And we prepared a few activities that will be led by different people from Polylog. And hopefully it'll prove interesting. There'll be a QA at the end, so please submit your questions and we're going to go through that. And the recording of this will also be available on the YouTube channel. We're not streaming experts. I think this is the first live stream.
Whoa, this is the second one. We did a test run yesterday and it went very well.
I'm sorry.
I only had to redo like everything.
I take it back. We are streaming experts, so it'll be a high quality experience for everyone.
There are no mistakes. This is all that you see was intended, so.
Yeah, exactly. So let me introduce the Polylog crew. So wait, what is the order in the live stream? I can go through that. Okay. In the top left we have Václav or Vasek Rozhoň, who I started Polylog with originally in 2021. Do you want to introduce yourself? Maybe it's better if everyone does their own introduction.
Yeah, maybe very quickly. So basically, my name is exactly the same as the name of Václav. So this all makes it extremely confusing. So this is why internally I call myself Vasek. He calls himself Václav. And I'm currently a professor at Charles University in Czechia. And yeah, we started with Václav a long time ago, and I'm very excited about what comes in the next 5 years.
Yeah, this was almost exactly after the first video we made 4 years ago, actually. So it's also like a 4-year Polylog anniversary live stream in a way. So then bottom left we have Risha or Richard Hladík.
Hey. Yeah, so I am currently a PhD student at ETH in Zurich. I kind of know all of these guys. I've known them for a long time, and I guess I don't remember exactly when I joined Polylog. It was like 2 years ago, or maybe something like that. Yeah, we are kind of doing some research with Václav as well, so it's kind of we talk about research stuff, and then in the middle of the conversation we start talking about Polylog stuff, and then back again. So that's kind of fun.
You're doing research with Vasek, right?
With Vasek, sorry.
Oh, this is. I'm gonna be confusing it too. This is not.
I'm confused already.
Yep. Sometimes.
And then we have Tom.
It's me. Yeah, I'm the recent addition to the team because I got burnt out working on my own videos and I don't have time. So it's better to work as a group than as a single person because you can focus on the stuff that you like and you can just leave the other hard work to others. And yeah, that's pretty much it. In the meantime, I like to climb and work on a climbing related startup. And yeah, that's pretty much it.
All right. And then there's me. I'm Václav Volheim. Yes, Václav, not Vasek, for the purposes of this video.
So you're confusing it too, see?
Yeah, I don't remember my own name. Yeah, I currently work at QTI in Paris. It's a non-profit AI research lab that mainly does audio. But we started Polylog when I was a master's student at ETH Zurich, where we worked with Vasek. I also lived with Risha in Zurich for a while before moving away, and yeah, I'm the voice you hear in Polylog, but as you can see, there's many more people that are not always in front of the camera. All right, so this is the plan for the live stream. We're going to have several segments. First, I'm going to do a little programming contest where I will go through an old round, or well, it's like 2 weeks old, of AdCoder and try to live commentate while what I'm doing, and the rest of the Polylog crew will also give their input and feedback. And you can ask questions in the chat about competitive programming or whatever else you like, and we'll try to answer those. That will last about an hour. Then we're going to do an algorithm tier list, right? That Vašek Rozhoň prepared, where we're going to take a bunch of popular algorithms and rank them from worst to best.
Because people like oftentimes argue what the best algorithm is, so we're gonna decide that once and for all, so nobody has to ever talk about that again.
Exactly. This is probably the main contribution of Polylog as a whole.
Putting up an archive paper after.
Exactly. Then the third segment is going to be run by Tom, and it's going to be about programming like simple bots for a strategy game that you will be able to take part in as well, right?
Yes, you too, everybody. It's a arena as many bots as there are vertices on the graphs, and there's quite a few of those. So we're gonna see, and either it's gonna be a fun programming bot challenge or a case study of how vibe coding can go wrong when implementing a server architecture. It's 50-50. I'm not sure yet. We're gonna see by the end of the live stream.
We did test it a bit, right? So
yeah, we tested it with like 3 players. So I mean, we know that it can handle at least that many, but yeah, but we're gonna see. It's gonna be fun.
I'm sure it'll work.
Yeah.
And finally, we're going to do a Q&A session, which we can say Risha is going to run it, and the questions will be distributed among all of us. There is a Slido. Is it called Slido? Yes.
It's a
link.
pin on the YouTube chat. You can click on that. Yeah.
You can right now. You can submit your questions there, and we'll be sure to answer them. All right. So that's the plan. Without further ado, I'm going to share my screen here with hopefully the correct thing. There we go.
You are live. Yep. Perfect. I see code, and
I'm going to put my browser there, and we're going to do the AdCoder beginner contest 420, because 420 is the country code for Czech phone numbers.
That is the reason.
That is the reason. Let's start in 1 minute, I think. Okay, perfect. So we're not going to do, I mean, the whole contest is like an hour.
Do you want to send a link to the YouTube chat so maybe people can try to?
Yeah. Let me do that. Oh yeah, I want to edit the schedule. Could you just let me do that now? I just want to add the time zones here. All right, you can see this. This is the link to the contest. Okay, so we're just going to go from the first task, and together we're going to try to, so first of all, there are 7 tasks that go from easiest to hardest. And if you've never done competitive programming, the idea is that you have to submit a piece of code for each of these tasks. And the code implements an algorithm that every time it gets a certain input, it needs to produce a certain output. And then these are automatically checked. And if you pass all test cases, the code is accepted. So there's a part where you have to come up with what the solution is going to be, and the part where you actually implement it. And there are tasks that are easy in one and hard for the other, and vice versa. This is a beginner contest, so we're going to start kind of easy, but they quickly get more tricky. So let's have a look at the first task. So we get integers x and y between 1 and 12, and we are supposed to find what month it's going to be 1 y months after month x. Okay. And then there is a section that describes the format of the input and format of the output. And then this is quite important. There are some samples that give you, that explain, oh, if the input is this is what the answer is going to be. So this seems to be a simple one. If it's January and we add 1 month, it's going to be February. Okay, so let's go ahead and implement this.
So do you usually have also maybe can you say a bit of background on like your relation to competitive programming, because it seems like you already have some some templates on things that you use quite often, I guess. So this is because I've seen this being quite a common thing when I like look at a competitive live stream where there's like a 50 template functions and there's like a importing utils that does like everything. So okay, never mind. Okay, yeah, I didn't see you scrolling up. Okay.
So this is, okay, I can explain my template, or maybe I will explain these when we actually use them. But basically, people that do these online contests often define sort of templates that have some boilerplate code that you don't have to write every time. A very common one is this sort of thing where you define shorthands for loops. And this is sort of more fancy C++ stuff that I will explain if we end up using that. And these are just some includes that allow you to use the things from the standard library, and using vectors and so on without std. If you don't know C++, maybe this doesn't make sense, but it's not too important to know. So I'm going to scroll here so that we don't see that scary stuff.
Thank you. I already feel better now.
Yeah.
Can you also use bigger font?
Yeah. Is this better?
Yeah.
Okay. Looks good.
Cool. So we're just going to read the input here. And now I'd like to do this, where I just increment x by y. But if we do that, then of course, we're going to overflow outside. But let's just, meaning, for example, here, 5 and 9. Let me run the code just so that you see what happens. I mean, it's sort of obvious, right? So I have this, this is like a custom macro or like function that I have that's going to compile the code and run it. And now it's reading input from the standard input, meaning I can type stuff here. If I type in 5, 9, I'm going to get 14, which is not correct, right? Because, well, there's no month 14. So we could do it with a modulo, but I think that, wait, let's see the inputs again. There will be like a trick. Okay, these are between 1 and 12, which means it can only overflow once. So I think the easiest way to do this is if x is bigger than 12, then we subtract 12. Because if we used modulo, there would be some sort of like problem because months are 1 indexed and not 0 indexed. So this feels safer to me because it's easier to reason about. Yeah.
Well, what we should do as other members of the Polylog team is to like vote on how nice the solution is for each problem, and then we can like as a jury decide, because this is vile. But
you don't like this?
No, I'm kidding. I would have used the module because it seems like pretty intuitive, but this is just like a straightforward solution that's really nice. Like I don't think I would have thought of this because I didn't look at the input size for the like y. So I was like just any number, whatever. But this is pretty cool.
I feel like I would have to think about what happens with the 0.
Because like
But,
you have to do minus, then mod, then plus, or some stuff like that. And it's kind of,
yeah,
you know,
exactly. And it's often best to do the dumbest thing or like simplest thing that you can afford. Okay, so here's the, I mean, it's a bit zoomed in, so that's why it doesn't fit. Let me put this full screen.
Oh, I'm increasing your volume a bit because there's a comment that it's a bit too, should be good now, hopefully.
Yeah.
I'm gonna try to monitor the volumes. It's like a balancing act because every time somebody moves away, now it's suddenly less. This is like, yeah, fun times. We're professionals at streaming.
Yeah, exactly. Okay. And so this is the submission page, and it got accepted. So they ran the code on a bunch of test cases, and every input produced the correct output, so we got accepted. Great, so we can move on to the second task, which is most minority.
Okay. So one more question.
Okay,
so
yeah.
right now you're in the competition, or is this just like,
so this is what's called a virtual contest. So this contest ran, as you can see here, some week ago or something
some days
like
ago.
that.
Now it's just like rerun or for you, I guess.
So
right?
so what you can do is you can look at virtual standings. So it's as if you were doing this contest, and here it tells us. Oh, okay. So this is actually just from the like virtual people who are submitting virtually. So it tells me I'm in the place 371 compared to other people that did this contest. I think if I do
solved in 30 seconds. Okay, that's
virtual standings.
Yep.
Oh yeah, some of these are like insane, like literally submitting 30 seconds after reading the thing. No, I think that's legit.
Crazy.
Like people are.
Yeah, I mean, yeah. Like
fast.
I join like Advent of Code every year, and people on that are crazy. Just like, I mean, the recent year has been a bit controversial with the LLM stuff because like the first few days were solved in like seconds, and then it just dropped off because the LLMs were no longer good enough.
Oh, okay.
But it's kind of
okay.
Yeah, it's a similar concept, I guess.
I've never done that, but I know people do it. Yeah.
It's really fun. It's really fun. You should really do that. I mean, if you like this stuff, then Advent of Code is that, but Christmas vibes. It's amazing. It's so much fun.
Okay, that should give it a go. I know also a lot of people like Project Euler.
Ooh, that one, yeah, but that one gets very mathy very quickly. I like the Advent of Code is more like implementation, but Project Euler, I feel like when I get to like the 100th problem, it's like I gotta know some math, otherwise it just like feels completely impossible. I calculate this thing mod 1,000,000,007. It's like, okay, what do I even do here?
Oh yeah, classic 1,000,000,007.
Yeah, yep. Okay, nice.
The smallest, what is it, 9-digit prime? Or am I off by one?
Yeah, I was thinking it's a prime, but it's cool that it's just that value because it's like the right size and feels, yeah. Cool.
That's a common value in competitive programming. And then also 1 billion plus 9 is also a prime. Okay, let's read the task 2. So we have an odd number of people, and then they vote. Okay, is this like one person votes m times? Like everyone votes m times? Okay, yes, apparently. Right, so we have n strings of length m. Yeah, okay. People who are in the minority receive 1 point. Okay, and this explains how ties are broken. Oh yeah, x equals y never occurs. X equals 0 or y equals 0? What's that? What's
Could you maybe explain it a bit slower, because it's like it's pretty particular. The format is pretty terse in the sense of it only gives you the information that you need.
I usually look at the sample inputs and outputs because those are the clearest. So here we have 3 people and 5 rounds. So the x-axis, if you imagine this as a table, is time, and the y-axis is which person is it. And sorry, I need to read the rest of the task to see what we're even supposed to do. X people chose 0 and Y people chose 1. Oh, okay. So this is if everyone chooses the same thing, then everyone gets 1 point. Otherwise, the minority. After finishing M votes, find all people who have the highest total score from those votes. Okay. Okay, let's do it. This seems like a straightforward implementation task. So there's not much here to figure out. We just do a sort of simulation. I'm gonna add one more thing here.
So do you
I'll get.
Do you plan on reading the entire matrix?
Yeah, let's see. Okay, so this is the sample input. So let's keep it here. Let's put it here. Okay. So we read end M. Let's call this A. And now I'm going to use, so I can actually do this in C++, which will read the whole vector of strings. And that's not a standard C++ feature, but it's because I have this, wait, which one is it? So I wrote this years ago, but I think it's this, yeah. Oh no, sorry, that's the output. This. So this basically defines what this operator should do for vectors. And that allows me to read this entire vector in one go instead of using...
Sorry, Vasek, can you just delete those 10 lines of code and do it so that even I understand it? Sorry, I'm just looking at this type name and I'm scared because, you know, it's like 10 years since I have seen this word and I'm getting scared.
Okay, fair enough. Let me just show you what it does.
Just a simple for loop, please. Just one for loop.
Yeah, so if you can see here, I just read A and I printed A, and this is what it does. But I can translate it into for loops. I just don't think it's the most interesting part, but we'll do it for this task. Yeah, so now you can see as I deleted it, it's now complaining. So for loops are actually rep, or would you prefer a for loop?
This is perfect.
So this is a macro that does a for loop. And we read the ith element. And this is equivalent to what I had before there with the templates. I mean, I agree that it's sort of magic, but I think it's also nice to see how sort of competitive programming works in practice, because if we were doing like proper C++, we would also like not do the using namespace std most likely, and we would like qualify all of our like standard library calls here. But as I learned after I stopped doing competitive programming, real world C++ actually looks pretty different from contest C++.
Did you learn that only after? Oh no.
I was convinced that I'm a C++ expert. I'm no longer convinced of that.
You know, Tom, so sometimes when you are looking at these top competitive programmers and you are looking at some kind of a graph of their rating and the rating goes down, then like this is basically the time when they learned how to program.
Yeah, exactly. That's like no, they got a job and they're like, the employer is like just looks at the code and like, okay, this is not, you cannot be defining for loop as a macro. We cannot have that. That is. But like, I mean, it makes sense because you need like every character counts, and you're the only one who needs to read the code, and it compiles to the same thing. So like, might as well, you know. But
and you know, you are competing with the guys who have it in 30 seconds. You want to have it in 28 seconds, right?
Yeah.
Not like exactly. Yeah. Yep, makes sense.
Oh my god. I'm trying to disable this autocomplete or this like IntelliSense because this is killing me. I can't see shit.
Yeah, maybe just don't import like 30 libraries in it.
No, this is
it
yeah,
is
I
nothing
mean
else?
that's let me try to is it oh that's better. Yeah.
Nice.
Yeah. Oh yeah. Good old crappy autocomplete. Yeah, but feel free to also talk over me and I'll just do a little bit of implementation here.
I mean, like the task seems pretty straightforward. So I guess you're just gonna do a double for loop thingy and just count and add. That sounds pretty much like the only thing you can do, or is it something more
Yeah,
extensive? Because like you have to read the input anyway, so you don't get better than just doing a double for loop, I guess.
yeah, not really.
Yeah, like you said, these initial, oh my god, I'm blinding myself. These initial tasks are more of an implementation challenge than like an algorithmic one, because I mean this is just like you read it and it tells you what you need to program, so it's essentially just like dealing with the input, reading everything, then going through it. So it doesn't seem like, yeah, it doesn't seem like much to say except,
Oh,
yeah,
it's Python.
except that's how you do it.
Yeah.
Like I was wondering if it's maybe possible to not make it a like an m times n in memory, if you can just like read line by line, but that doesn't seem to be particularly easy because you need to track like for each vote, and so it's kind of in the wrong order.
Yeah, it's more of a, like for example here I need to decide a plus minus 1. I think this is correct. Like this would be wrong.
It never
Because
occurs, so I don't think.
because we're rounding down here.
I
and
think
then
in the task it says that since n is odd, x equals y never occurs. Maybe this is it.
oh yeah, but I think this would still be wrong because n over 2 if n equals 3 would be 1.
Oh yeah,
and
you're
then
doing it here. Ah, yeah, sorry.
we would only
Yeah.
get 0 and not for like then it would be balanced like this instead of like this.
Sorry, yeah, you're right.
Yeah.
Mhm.
So if there are fewer ones, then we're going to actually let's put the for loop here. So we're going to assign the points. Maybe we could have even oh yeah, I lost auto formatting by oh no. Oh, okay. There's no way I can get both.
But it's the true programming experience. It wouldn't be
Yeah.
it wouldn't be reasonable if it just worked. You
Programming
gotta have some of those.
this is biblically accurate programming.
True. True. I'm gonna maybe look ahead on the next task to see if it's reasonable.
So here I'm assigning the points to whoever was not the minority, and hopefully this is correct. And now we're supposed to output the person numbers with the highest score in ascending order of person order. Oh, that's annoying. So now after doing all this, we're going to need to... Does this work? No, max doesn't work over vectors. That's pretty annoying.
I think you do have to sort, I guess. Or
we would need to do sort of an argmax there. So what I'm going to do is this variable is named mx so that I don't shadow the built-in max. Max of mx and points of the ith person. And then I'm going to go over them once again. And then if points I equals max, then we print, and now we need to do I plus 1. They don't mind trailing spaces because this will leave a trailing space after the last participant, but that should be fine. And now if we run this, I don't think that's correct. So what I'm doing here is I have this file in, and then I'm running my code on the input here. And what it output is 1, 2, 3. And if I remember correctly, the correct output is 2 and 3. So let's see what's going on here. So usually what I do to debug is print certain variables. I think this is not going to work. Yeah, because I can't print a vector now. So what I'll do is I'll do a little for loop here. I'm going to print that. And I'm going to print the end of the line. So these are the, so my program thinks everyone got 2 points. So let's instead do this after every round, and then we're going to see what it thinks after every round. We're going to compare this with the output. This is a bit annoying because it's transposed compared to what we have here, but we'll figure that out. So here it thinks that the third person got 1 point. That's correct because he was in the minority. Here the middle person got 1 point. That's also correct. Here no one got any points. That's not correct. Everyone should have gotten a point, which is...
You have an M instead of an N or something like that?
Yeah, looks like it.
But like, it shouldn't matter anyway, right? Because like if everyone gets a point, like it doesn't affect like who gets the most points.
Yeah, good point. Haha, no pun intended. Okay, so here the second person got a point. That's weird. This seems to be a bug. No, wait. The first 2 got points, which is not correct, right? Do you see the bug? Like something is wrong, I guess, when zeros are the majority, because the ones should get...
So...
yeah, if you see the bug, then shout at me.
Shouldn't there? Okay, no. Yeah, the equal sign looks a bit... I mean, if I were debugging it, what I would do, and what people shouldn't do, is just try to do an equal sign when I'm comparing the ones, and try to run it. Because I don't like to think, I just do, and then I see the output.
Oh, like this? Oh yeah, that's actually a good idea.
Yeah, like okay, yeah.
This is the so-called proof by submit technique.
Exactly. So I would do this first, and then I would think. I think that's much better than... No, I'm kidding.
No, I think you're actually like non-ironically correct. Like,
well, that would be very sad, but
and it looks like it works now,
I mean,
right?
it says 2-3, which is concerning, but yeah, okay. We have a comment as well. Is it the versus? Yep, it probably is. If you wanna.
So let's try this. Oh, that didn't work. Why not?
Maybe because you have the...
That should be fine.
Oh, because it just reads.
Because it just stops reading, but something is wrong. Maybe I'm swapping I and M somewhere else.
Cool. Maybe when you fix that, could you also talk a bit about the run command, because there's like a nice debug here that looks pretty interesting. I've never seen that.
Oh yeah.
Because it's pretty cool. Because mine just crashes with the signal one, so it's like, you know.
So okay, this for some reason is written in fish, so that's the shell that I use. And what it does here, it does some things like it doesn't recompile if the file was already run with the same and I didn't change it. And then I think the magic command here is fsanitize equals address. As you can see, I'm using a modern version of C++, C++ 14. It's just 11 years old. Yeah, but I think fsanitize equals address is what gives you this. Okay, let's see why. Okay, let's reintroduce these prints, and then we're going to see if anything is printed. No, so it happens pretty early. Is it? No, this seems correct, right? So
one
C++
thing that's
is
not so nice, sorry, that's not so nice about competitive programming is that the code is a bit hard to read now that I'm trying to examine where the issue is.
I think now your matrix is of the dimension n times m, but you're indexing it as m times n, no?
I am
Or
indexing it.
J.
So this is n.
N times m.
Oh no,
Points.
it's alright.
Oh, I think points should be
Ooh,
n
n.
actually.
No, it is,
Yes.
yeah.
I think this is the issue.
Yeah.
Yeah, there we go. So it prints 1, 2, 3, 4, 5 at the end. That's correct. And now I would just submit this because
Oh, I only now see that you need to print the people with the most amount of votes, not like the total ordering. Okay, never mind. Not the ordering.
Yeah, and let's try the third input that says 1, 2, 3. So that seems like we're good. And now we're gonna submit.
The moment of truth.
Yeah, I would stop at around 8 with this. So let's see, we probably have time for one more. 2 more if we're good. Okay. Length and integer sequences. Okay, so we have 2 integer sequences. Oh, it's a data structure thing. So we have queries that we need to do on these 2 sequences.
So maybe we get time until 9 if it's a data structure thing.
Oh, we good. It's gonna be okay. Character C. So there are 2 types of queries. Query A, it says change AXI to VI. Okay, so it says set the value of a single element in the first sequence to VI. Otherwise, change one value in the other sequence. And then we're supposed to output the sum of the minima. Okay, so let's go through an example here. So these are 2 sequences. Okay, let me put this on the right side, and I'm going to write here.
You can maybe modify the state in real time, so you can kind of run through what's happening.
That's a good idea. Yeah, let's do that. So we're going to. Okay, so this is the input, and at the top, is this big enough? We're going to have the 2 sequences. So first A 2 should be changed to 3. So maybe I'll write it like this. So this is sequence A, this is sequence B, and so we're going to change that to 3. And what we're supposed to output is the sum of the minima. So that's going to be, let's call this O for output. And so that's going to be 2.
So
3.
you're doing this kind of like online, sorry, right? Like with each query, you need to produce the minimum, right, for that given state?
Yes.
Okay.
So we're sort of going to keep this minimum, and then the sum is going to be 7 in this case, right? Let's see if that's what the output says. Yes. So this feels like it should be pretty easy. Oops, yeah, if I ask. Great. I do have Copilot disabled, right? Yeah, it hasn't been saying anything. Yeah.
The secret, the hidden technique.
Yeah, exactly. So what I think we can do is we compute this value once at the beginning, and then when we get a new query, it can only change in one position. So we're going to subtract whatever we had in that place. So for example, how did we start off? We had so like at the beginning A was equal to this, so the minimum here would have been 1, and the sum is 5. So we're going to keep this total, and then if we change this, we're going to recompute just this value, and this is going to change, and that's going to change the sum. Because the naive way to do it would be to recompute this every time, but very likely that would be too slow, because there are 10 to the power of 5 numbers and the same number of queries in the worst case. And that's typically telling you that a quadratic algorithm like this one, that would have time complexity O n times q, would be too slow. So we need something like O n plus q. This is like typical sort of communication in programming context statements, like the 10 to the 5th is telling you like no quadratic algorithms allowed. Cool. So this one, I'm going to keep these templates this time. So NQ, and then 2 vectors of length n.
And so the templates just do the reading into the like vector of vectors, right? Or vector of strings or whatever.
Yeah, just simple vector of ints in this case.
Yeah. Yeah.
Okay, and the values are up to 10 to the 9th, which means we should be careful because of integer overflows. So I'm just going to use long longs everywhere, which if you don't have to think about it, it's just easier and you're saving yourself a potential bug.
Okay, but so realistically, do you ever want to use just like int? Like when you think about the architecture, like is it practically the same running speed? Because it feels like
maybe Risha or Vasek.
Like because I would understand if you're doing some like struct stuff where you kind of need to pack things into like 64 bits, but if you realistically have an array of, I mean maybe you guys can speak to this, but for me, yeah.
Yeah, like I would say like it's twice as large. It takes twice as much space in memory, so like it can be like twice as slow depending on like if you're like CPU constraint or memory constraint. Like if you have an array of like 50 megabytes of data or 100 megabytes of data, then maybe like you want that might be a big difference. I don't know.
So it like practically it would be stored as like because if you would use something like int 16 or int 8 or whatever, then I guess that would be stored as like 32 bits, right? Or maybe is it just still the case that it would be smaller? Because from my understanding, stuff like this.
I think if you use like int 16 on like standard on like a standard architecture, it would be stored in like 2 bits, 2 bytes. So it would be smaller.
Okay.
But I think like 32 bits is like the sweet spot because you can represent like reasonable numbers, but it's also like smaller than using like 64 bits because it's like half the size.
Makes sense. So like dealing with data, this makes sense. But otherwise, if you just have like if you just have numerical computations, then it doesn't make much sense to use 32 over 64, or does it still?
I guess like you can start with like 64 bits if you don't want like to deal with overflows, and if that's too slow, maybe you want to go back to like 32 bits. See if it speeds things up.
Do you remember the kind of computation where we would be memory bound? Maybe you can talk about that more because it's kind of a tricky concept.
Yeah, I don't. But I would guess like if you have, I don't know, if you have like data structures, if you have like a heap or something, yeah, that's maybe like a dumb example, but like I guess in data structures you have a lot of pointers, a lot of stuff, and if you can like shave off some space, then you definitely like want to do that.
Like, so wouldn't this be, for example, like I was just writing a chess engine as a challenge against my friend, and one of the things that was, I think, pretty important is to, when I have a struct or something, and I needed to pack like the history for a particular chess move, it made sense to try to pack it into 64 bits, so it would fit more reasonably than it flowing over and actually having to, I guess, round up to like 128 or whatever. like in that case, it would make sense, right? Because it has to kind of add the padding to the struct so it can be reasonably stored. Is that something that like makes sense?
Definitely.
Okay. So in the meantime,
We're just stalling here. If you already have the solution, then
yeah, I submitted it and it worked.
They
so
work?
yeah.
Wait, so can you show the solution?
Yeah, so this is the solution. I submitted it, it worked. It's quite
Can you
simple.
explain the solution? Because
Yes,
I'm looking at a few letters.
Yeah. I mean, it's a very compressed style, and it's easier to read. It's always easier to read the stuff that you write yourself. What
we
others
can
have
see that
written.
there is an LL Tot, which is an Egyptian king, I guess, or what do we have here?
Tot is a competitive programming speak for total.
Oh, okay.
I mean, it's I don't know. I don't think that's standardized. I can't call it total. LL is short for long, which is something I define here, and it's super common. Like pretty much no one writes long. Everyone defines LL. It's also often because when you do like on-site contests, you don't have access to like whatever your favorite editor is. So then competitive programmers often work in pretty bare bones setups. Where like you have to save the keystrokes. I'm not saying this is good programming style, but it's like the conventions for competitive programming, like the constraints that you have to fulfill are different, right? But then you just keep a total at the beginning, and then when you do a query, you like subtract the value for that position that you're changing. You change the position, and then you just like add it back to the total after doing the update, and that way you always have the current total because it's just one position that changes and you don't need to recompute everything else. So we have like 11 minutes, so maybe maybe we can manage one more. Let's at least read the statement and see how it goes. So we have...
And it's a maze, and it's over.
And it's a maze. Oh my god. Let's...
oh,
oh my god, I already hate this.
And we are done. And okay.
Oh yeah. Oh my god. Yeah. There's...
So maybe we can look at the next one, or you know, maybe what we can do is we can just like try to solve them like, you know, on paper, right?
So do you want to do this one or the... Okay, let's just think about the solution then.
Yeah, but on paper sounds good because we can just like just walk through the solution together.
Okay, let's do that. Maybe Vasek, you want to have the honor? No? Okay. Then okay, this just tells us there is a grid. And these are the things that it means. We have empty, obstacle, start and goal, open door and close door, and switch. So I guess maybe the switches will switch what's open and what's closed. Takahashi can move to adjacent cells. Every time he moves to a switch cell, all open doors become closed door cells and all closed door cells become open door cells. Yeah. Determine whether he can move from the initial state of being at the start of the cell to being at the goal cell, and if possible, find the minimum number of operations. Okay, this is a pretty classic kind of problem. So what we would do here is like a breadth first search. So, okay, so typically when you have a grid, you want to think of it as a graph. And in this case, so if there were no doors, then we would just do breadth first search on this graph and find how to get from the start to the goal, which in this case would be by going here and then vertically like this. However, here there is, so then your position in the graph is just determined by your x and y coordinate. But here, what I think is what you can do is like you imagine a graph that's not two-dimensional, but like three-dimensional. And essentially when you step on a switch cell, you like go from the zero, from one layer to the other, right? So this would be much easier if I had a whiteboard. But imagine like you have two grids stacked on top of each other, and in one, the one kind of door is closed and the other is open. And in the second floor, one kind of the other kind of door is open and the first one is closed. And then whenever you step on this, I guess it's the, is it the X? No. Which one is it?
Question mark? Is it?
Question
Switch?
mark? I
Maybe?
forgot. Yeah, switch cell. So when you step on the question mark, you switch floors. Yeah.
Maybe can I, because like this is true, but maybe for me it's easier to think of these as just like you being in a particular spot, like your position is not just like where you are, but also the state of the switch. And this gets activated every time you step on the switch. So you're not like just searching through the space of the position where you currently are and walking through the maze. That would be like the regular maze. But your state also includes the polarity of the switch, like whether it's on or off, whether the doors are open or closed. And that's exactly the same thing as you mentioned. Like it effectively means that you have a graph on top of this, where this is the state of the doors being switched off versus on, and you walk you walk from one side of the graph to the other based on whether you step on the switch or not. But it's conceptually more simple to think of this, okay, right now I have to remember that I am here, and I also have to remember that the switch is in the current phase. And then it's much easier to sort of think, okay, how do I generate the next state? I can take sort of the current state, I can take the graph, and I can produce the future states. And this is like a very simple concept that can kind of like help you solve essentially like all of these state search problems without like without explicitly defining the graph you're working on. So it's kind of like a nicer framework for me to think about problems like this.
Oh yeah, for sure. I mean, like when I would write this, I wouldn't explicitly construct the graph, although that's something that you could also do. But yeah, like represent the state with like 3 dimensions.
Yeah.
Or you can think of it as like dynamic programming, which is probably not something we want to get into here. But
a dynamic programming?
I mean, BFS is kind of dynamic programming, right?
I never thought of that. Okay, interesting.
Well, yeah.
I guess it is.
Like ish.
If we squint the eyes.
Yeah. Should we look at one more?
Sure.
Reachability query. Oh, it's another data structure one. Okay. So this time we do have a graph with n vertices and 0 edges. And they're colored, so initially they're all white, and now we have to do a query where we add an undirected edge connecting two vertices. If one is white, change it to black if it's black, but only one of them apparently. Okay. Oh no, sorry, those are different types. Okay, I see. Determine whether a black vertex can be reached from vertex V. Oh, whether a black vertex by traversing 0 or more edges. Report yes if reachable. Okay. So my first intuition when I see something like this would be that it's like a disjoint, what is it called? Set union? Disjoint set data structure, where you have, okay, maybe let's look at some pictures, where you have like a graph, and then you can do, oh yeah, algorithms for competitive programming, exactly. And then you can like join cells, join vertices, and ask whether they're in the same component. So that might be like a building block that we would use here to figure out if two vertices are connected, but we somehow need to take into account the color of the vertex. Any ideas?
It's not quite, because I guess you're kind of, I mean, yeah, you're doing that, but you care about like the number of vertices in a component or something, whether they're even or odd.
Yes, I think you're like, you want to know if in your component there is like one black vertex, at least one black vertex or not.
Yeah. And
Yeah.
so it's like even or odd count, would it be, or something like that, or
just
maybe
more like
it's more
more than 0, right?
Yes.
And then
oh no, it's not. So not even or odd. Doesn't make
And
sense.
then I guess when you're like merging components, you need to
add those two numbers together, right?
So just for each component, you would keep this number of like black vertices in the component. Okay. Yeah. This would be kind of fun to implement, but I'm not sure I can do it in 3 minutes. Okay. So yeah, let's maybe just quickly explain the idea in a little bit more detail. Like we would use the disjoint set union data structure again. I mean, again, wait, let's see if we find a better image of what we're trying to do here. Yeah, maybe this. Oh, beautiful.
Like the data structure itself, like the implementation, I guess like we don't care, no? Like we care about more about the API.
Yeah. I mean, for the implementation, it matters because you are maintaining some root of the component, right? And then you would have to store information in the root and make sure that when you're doing this union operation, you are propagating. Because like, for example, if I have something like this graph on the right, and then I need to do a color update on graph H, then I would first find the root, and then I have to like maintain the number of black or white vertices there, right? If you see what I mean, like in this, or did you mean the API is like find root?
I mean, it's like union find. It's just like union find, right?
Yeah. And then the color of the vertex we need to store for each vertex and not just the root, because we need to know if we're toggling the color to black or to white. Yeah, unfortunately we don't have time to implement this anymore, but this is
union find.
How we would do this. Also, people often have sort of libraries of algorithms that they reuse. So for Codeforces or AdCoder, like here, I think it's fine to like copy code that you have ready from before. For on-site contests, no, except ICPC. Sorry, this is maybe a little too technical. Okay, yeah, thank you. We're going to stop the competitive programming segment here. I hope it was interesting and that you learned something. If you're a competitive programmer, you probably knew all of this already, but if
you're
not,
already typing the rage comment on the on the Q&A, like why did you
what?
No.
Exactly.
This was really nice. Thank you for the segment.
Yeah,
yeah, I had fun. I haven't done any programming contests literally in more than 3 years, probably more. So I'm coming out of retirement for this. It's kind of nice to see it again. And
I'm kidding.
now we're going to do an algorithms tier list.
Yeah, let's do it. Yeah.
Maybe Vasek, do you want to start with the recap of the stream and what we're going to do next and everything for people that have just joined?
We can also have a short break. I'm not sure what the right approach is. Anyway, here's a short recap. So we already had the first part by Václav. So he was presenting some competitive programming stuff. Now we will do a tier list of algorithms together. We will rate algorithms and decide which ones are garbage and which ones are amazing. After we are done, Tom will take over and we will play games against each other. And at the very end, we will have Q&A. But you can already ask us questions for the Q&A. So please do that. If you get bored and ask us a question. If you don't want to ask us any question, you can still go there and you can +1 some of the questions if you want to hear the answers to them. Okay?
And yeah, I mean, if you want to take a 5-minute break, that sounds good, and then we can come back. How's that sound?
Yeah, I don't really have to take it. I really have.
Well, we just keep on rolling then. Sounds good.
Keep on rolling.
All right.
Okay, let's go.
Just get some
so
water.
Tom, in that case, can you let me share the tier list?
No. Yeah, no, share, and then I'm gonna switch it to your screen. Let me know when you're ready.
Okay. This looks good.
Looks good to me. Switching to your screen. Yep, switching to your screen. There you go.
Okay. So this is a website that I vibe coded in a few afternoons, and actually, you all can join me, and you all can go to this website. It's polylog-cs.github.io/tierlist, and you can rate algorithms with me. And at the end, we can all save our rankings and see some kind of aggregate rankings together. Okay.
Just posted it in the YouTube chat, so if you want to do that, then yeah.
Okay, good. So here are some algorithms that I have selected. It's kind of like incredible random selection. I do not really claim that this is some kind of representative sample of algorithms that you encounter in your programming life. I tried to select a few algorithms that you kind of learn in some introductory courses to programming. Then I added a few more algorithms from some kind of various subfields of computer science so that we also have some kind of breadth. Okay. Here is how I plan to do it. We have 5 tiers: garbage, solid, great, masterpiece, legendary. And each time I will grab an algorithm. I will say a few words about that algorithm. It's not supposed to explain what that algorithm does if you don't know it. If you don't know the algorithm, maybe just wait for the next one or check Wikipedia or something. If you are on the page, you can also click on the algorithm and you will see some quick description of it.
Oh my
and some
god,
links.
that's damn.
Wow.
This is actually, yeah, I actually have not read it. It's written by Claude.
So the
please
vibe
take
is
it
very strong within this one.
so please take it with some grain of salt, and if it's wrong, please blame Claude and don't blame me. Okay.
That's
When
almost
Claude-
like the
when
end
Claude
user
code-
agreement for all the all the bots as well, so it's fine.
Sorry.
I don't know. It's almost like the end license user agreement when signing up to the chatbots anyway, so that makes sense. Yeah.
Right. Anyway, so here's the plan. So I will always say a few words about that algorithm, and then I will ask you guys to tell me where you would put that algorithm, and then I will make some final selection. Okay. So let's start with backpropagation. This is like really an algorithm that probably many of you have heard about. It's an algorithm that can train neural networks. So you have some very deep, very large neural networks. And usually when you run the neural network, you start, let's say, on the left. You are kind of running the signal through the network until you arrive at your output on the right. But there is like a really cool thing that you can do. So you can, if you want to train this neural network, you kind of have to compute you have to differentiate it. You have to kind of compute how does the output change if I change a certain weight a little bit. And this can be done incredibly quickly if you, in some sense, run the circuit backwards. And this is called backpropagation. Incredibly fast, linear time, incredibly effective. Okay, guys, so what's your opinion? Where should I put it?
I think as a machine learning professional, I have to go at least masterpiece tier.
Okay.
But it's, I mean, on the other hand, it's not really doing anything that's surprising, right?
Yeah, but it's like the
this is like a big question, right? Like, if we were talking about, multiplying two numbers, like, multiplication is like really great, but maybe also it's not like the most complicated thing in the world. So like, is multiplication masterpiece or legendary?
Isn't that like all the algorithms? It's like, oh, it's just incrementing numbers.
Yeah.
At least masterpiece for me. At least masterpiece.
Okay. Richard?
I agree, but I would reserve for legendary for for something real special.
True.
Okay.
Yeah.
Well, let me put it to masterpiece then, and let's roll on. Okay.
Maybe we can reconsider
BFS.
later.
Yeah, we can reconsider, exactly. Okay, the next one, BFS/Dijkstra. So that's breadth first search. I actually think that some of the links shows some nice animation. So This is right. Here we have an animation of breadth first search. It's an algorithm that kind of starts in some vertex, then it kind of starts searching in all directions at once. It's like you kind of spill a bucket of water in that vertex, and then the water kind of goes in all the directions until you reach the target, the destination. It's the great algorithm if it's kind of the algorithm if you want to find a path in a map. We actually have a video on A-star algorithm, which is kind of like BFS on steroids. Actually, I should say that like there is this algorithm called Dijkstra, which is basically like BFS for weighted graphs, and then A-star is some kind of additional ideas on top of that. So this is a great algorithm used to find shortest paths in maps all the time. It's also relatively simple. So where should I put it?
I think Dijkstra's masterpiece.
Really?
It's like,
okay.
Yeah, it's like you say algorithm and it's like you just think Dijkstra. It's like, oh, I would put it masterpiece. I think it's an OG one.
Okay. I mean, it is definitely OG in the sense that it's like one of the first algorithms that people came up with after they actually built the computers, right? So I mean, Dijkstra came up with it in 50s, and maybe somebody came up with it like even before that, right? Like Claude says like 40s, 50s. So it's definitely like the OG graph algorithm.
That means it's kind of trivial, right? Again.
Exactly, yeah. Mm-hmm.
That's fair. That's fair.
So Richard, where would you put it?
Like BFS is trivial, but like Dijkstra, I mean, the proof of it even working, like I think it's not so trivial, no? Like the idea, you do these like relaxations and stuff. You have this like monotonicity. I don't know.
Yeah, there are definitely some kind of like cases you have to care about, like, you know, what if some edges were negative? It would then actually not really work that well. So there's definitely some kind of subtlety in there. That's right. Yeah, so it kind of feels like great masterpiece. I don't know. Let me put it in great because we don't have anything in great yet, and maybe we will reconsider. Okay, next one, binary search trees. This is again some kind of like a meta algorithm. Like all kinds of algorithms could be thought of as binary search trees. So this is a data structure that stores some numbers, and the numbers are stored in a tree, where in general it's always the case that like the left number, the left child of a node holds smaller numbers, and the right child holds larger numbers. And there are like all kinds of ways of implementing these type of trees. So you may know red-black trees or AVL trees or splay trees or B trees. Actually, Tom has a great video about B trees. And B trees are actually used in practice all the time. So it's also a very practical algorithm. Okay, but where does it belong?
I would put garbage. It's a hot take, I know, but it's just like working with it is just like yuck. Just like I want to remove a node. Okay, well that's a pain. I want to add one. How do I do this? It's like you know. You gotta go left and you gotta go right all the way. It's like, ugh.
I agree. I think no one is ever excited about binary search trees. It's just like what you have to learn. Like they're super useful, but no one's gonna be like, oh my god, check out this cool new binary search tree that I just read about. Like,
true. And it gets worse.
So
like,
have you guys like heard about splay trees? Like, you know, what kind of rock have you been living in like the last 40 years?
I actually like AVL trees the best, so. No, I'm kidding.
So Richard, like, would you put it above garbage or like would you stay in garbage?
Definitely. Like I would put it at masterpiece level. So I think this is gonna be very controversial.
Oh my god. Okay, well this
in that case, let me try to find some kind of compromise. I will put it in legendary.
Whoa.
Wait, any explanation?
Okay, Bogosort is the next one. So Bogosort, it's the first sorting algorithm that we have here. We will have several sorting algorithms, and Bogosort is actually maybe the simplest one. You just shuffle your numbers randomly. You check whether they are in a sorted order, and if you are unlucky and they are not in a sorted order, you just repeat this. Okay, incredibly simple algorithm. Efficiency may be the weaker point of it. Where should I put it?
Like it's solid. You know it's correct because you're just checking if it's sorted. So like it can't go wrong. I mean, depending on the implementation, it can be slow, but
It definitely scores a lot higher in fun than binary search trees, but like objectively speaking.
Okay. So you would say it's great, or
Like what
is that in
else are
your
we
competitive cookbook?
what else are we gonna put in garbage tier, I guess, if we're not putting
True.
Bogosert there?
Yes.
okay. Okay.
Like for the mean
Let's put it
potential,
in
I would say
garbage.
solid, but like objectively, I'm sorry.
Okay. So speaking of
Tough crowd.
garbage, we have bubble sort here. So this is just like a pretty bad sorting algorithm. I never really know what this algorithm does or like why is it working. Works in quadratic time. Okay, what's your opinion on this one?
It's just strictly better bubble sort because bubble sort you just sort everything random. But bubble sort you're like, if I did this, I don't need to shuffle everything anymore. So it's like a strict improvement. So I think it has to be at least above bubble sort.
I actually like strongly disagree with you. I know you know like in Bogosort, I actually like understand like why somebody would like talk about this algorithm, right? It's like not confusing. Like Bogosort is slow, but at least like it can teach you about like what the factorial sign, how to write factorial sign or something like that. But like bubble sort, I think it's just like outright confusing. Like like what's the reason why bubble sort works? It's like a bad implementation of selection sort, right, or something like that.
Yeah, true.
But then like why do you even teach it? Why don't you just teach like what select sort is?
But on the other hand, like if you have something that's almost sorted.
Exactly.
Like I remember once we played like a game where the goal was to sort like an array in like using simulating a computer in like by people, and how to rate this. Like then you have like some almost sorted arrays, and you want to like say which team like performed the best. And the solution is to just run bubble sort and like count how many steps it took before it was sorted. I don't know, like that feels pretty useful to me.
Okay.
Yeah, that's a common use case. With their human powered computers.
I would say like yeah, I like I would say
solid. It's solid. Yeah.
Solid. Okay. Yeah, let me.
And also we got a comment about infinite worst case time complexity, which is nice. So it has to be above Bogosort, I think. Like.
Okay. Okay. I will put it into solid, and then like when we are not watching for a few seconds, I will put it here, and yeah, everybody will be happy.
And by the way, we can also like have like a relative order like among the categories.
Yeah, exactly. This is actually how I think about it. I think about like BFS being better than binary search trees.
Yep. Sounds good.
Mm-hmm. Okay. Another sort, bucket sort and radix sort. So all the viewers
masterpiece
now know pretty well how that algorithm works. So what do you think?
Anything that we cover is a masterpiece.
Actually, I never asked you about the Frankfurt trip. Did you get to use the machine or only supervised?
You saw the video.
I saw the video,
but you were one of the people making the video. What do you mean?
I watched the material, but I mean like, was it like here? Because I saw like in some of them it wasn't you putting the stuff in the machine, right?
Oh, I mean, I think we could have, but we were too scared. So we just the footage that's running the machine that was not us.
Because like I saw the raw material, but I have no idea what the context is. Like there's a video of you turning a button, and I'm like, okay. I guess
we did that, but
thing.
I was scared to do anything more. Yeah, we did turn the button, but I think anything else is like if you just press the wrong button and it explodes, it's like it would be awesome footage, but I think we'd be barred from ever going there again. So.
Yeah, probably.
Vasek, what just happened?
So what are you saying about bucket sort / radix sort?
Wait, did he move it? I didn't look for a second. God.
You are saying masterpiece, really?
At least,
It's a
you
little
know, to be
strong.
fair, until the video, I really hated the algorithm, so it's at least good, great.
I would put it like here, maybe.
Yeah,
That's
sounds
bad
good.
Like the
marketing.
right place. Yeah. Okay, let's go for DFS, depth first search. So this is basically how you solve a maze, right? You just like go on and you keep on running, and when you return to a crossing that you have already seen, then you try the next road, and this way you kind of cover the whole maze in the end. So, what do you think?
I like the recursive implementation. Like I think it's a lot more fun to implement than BFS, where it's like, oh, I'm gonna manage a queue, and then I'm gonna go through my vertices. Where it's like, no, I call myself, and it's gonna solve everything.
Yeah, okay, but that's only because the language is hiding that underneath.
Yeah. I mean, who cares?
True. I mean, I think the concept of like DFS is like tied closely to a lot of other algorithms that like do recursive stuff. So like the concept of doing something recursively is like very tied to DFS. So it's
Maybe,
at least
yeah.
like similar to BFS in terms of like how legendary it is, I would say.
I kind of feel that like DFS and BFS, or at least in my books, they
Yeah.
are kind of next to each other.
Yeah.
I would actually put DFS like behind BFS because BFS is actually useful, you know, like you know, in maps and all kinds of applications. Like you actually do use like BFS or Dijkstra or A star or something, but like DFS, like not so much, right?
I don't know.
Like
if you
you
travel.
know.
Sorry, go on.
No, I wanted to say that like you know, if you look at implementation of I don't know GCC or something like that, you will probably see like all kinds of applications of it, or you know some kind of compilers or some kind of like heavy complicated code that works with some kind of graph structure. But it just all feels a little bit technical to me.
But also, like if you traverse a tree, like if you okay, this is gonna be controversial, but if you traverse a binary search tree, you're traversing it in like DFS, like if you want to list it in like sorted order, right?
Yeah,
Does it
I
make
mean
it
you
better
can
or worse?
you can probably argue that like whenever you use for loop, you are using BFS over some special graphs or something, right? But I wouldn't put that much weight on it.
I think behind BFS.
Yeah, let me put it here. Let's go on. Diffie-Hellman key exchange. So actually the true reason why I included this one is that we will actually have a video on this. So this is a good time to let it know to our viewers. We are planning to make a video about topics related to Diffie-Hellman. And what this algorithm is about? Well, it's a crypto algorithm. It's an algorithm where two people kind of start without any shared secret, and basically they send a few messages with each other, and at the end they have some kind of shared secret. They have some kind of number that they both know, but nobody else knows that number. So it's of course like really one of the cornerstones of cryptography. This is like something that people came up with in 70s, actually even earlier than that, because you know in like 60s 70s these kind of organizations like NSA, they were actually like you know, a few years ahead of the public research. So actually they had this algorithm even before 76. But yeah, this is really like the cornerstone of cryptography, together maybe with RSA and a few other basic algorithms. So
I would say the first masterpiece, because this is one of the algorithms that just feels like magic. I think if like sorry, no, legendary, because if you have like a I feel like all the legendary algorithms should have some form of like magic, where you're like the first time you look at it, you're like this shouldn't work, but the more you kind of look at it, you're like, ooh, this is like very nice. I like this. I think that there's like, maybe it's a bit controversial, but I think the algorithms in legendary tier should just have this like this spark, this like
aha moment.
Yeah, exactly.
And I also, I guess, like just based on the number of how many times it's used every day.
True.
True.
Yeah.
Like every time you
Yeah,
make
I
a
also feel that
connection. Yeah.
yeah, this is really like the cornerstone of like the whole field, right? So
Mhm.
I think we can argue that it's legendary. Yeah.
Yep, sounds
Like
good to me.
it's cool
Okay.
and practical.
Yeah. It just like kind of like checks all the marks, right?
Mhm.
Okay, added the distance. So you have two strings. You want to find how similar they are. So we are basically talking about, I think it's called grep, right, in terminal. So you have two files. You want to find all the changes in those files.
Like
And
diff.
Is that grep?
it's diff.
That's
Yeah.
Okay, either diff or
diff, it's
grep or
probably
both
diff,
of
yeah.
them. Yeah. So you want to find all changes, and basically what you count is that like maybe changing one letter to another, it costs you one. Maybe adding a letter is another operation you can do. Maybe removing a letter is an operation you can do. And you basically want to find like what is the smallest number of operations you can do to change one string into another string. So this is pretty practical. Like as I said, grab diff. That's pretty useful. Also in bioinformatics, when you have all kinds of genome sequences, you want to find the difference between, because typically you will have some sequences that are very similar, but with some small changes. And the way you solve this is dynamic programming. So you basically build some kind of table and then you walk in the table. You can also think of it as kind of walking through some kind of graph that you define, or as a simple example of dynamic programming. This is actually like sometimes maybe like literally the first dynamic program that people see in undergrad. So what do you think?
It's dynamic programming, so it's garbage.
Okay. Any other opinions? I mean, it can't be behind bubble sort, right? Come on, guys.
Oh, it can, it can.
I would put it in like solid. Yeah, it's not super exciting.
Yeah.
Okay. Okay.
Despite the pitch.
I'm happy with
Euclid's
that.
algorithm. Yeah, it's like so boring that I will just not talk about it anymore, and I will start talking about
Okay.
Euclid's algorithm. I think we could kind of argue that this is like the OG-ist algorithm we have here, right? It's kind of like the oldest one. I'm not sure if there is like any algorithm that like before Euclid. Maybe some kind of like adding two numbers or something like that.
Bogosort, I think Bogosort was before Euclid. That was like a caveman who was just kept shuffling the stones, like
Okay.
and then suddenly has it, and like 100%, 100%.
Good point. Yeah. Yeah. Anyway, like this one, it's kind of OG. It's computing GCD of two numbers. GCD is greatest common divisor, right? So it's like the number that divides both of them, which here is 2. Like the number 2 divides both of the numbers, but there is really no larger number that would divide both of the numbers. So why would anybody care about computing this? I'm actually not sure. Like,
What? What?
That's not a good. Aren't you trying to sell this? What is?
Like cryptography, no, or something?
Exactly.
Modular arithmetic.
So like number theory is kind of pretty useless, except of like this thing that like all cryptography is based on it, right? So yeah, like whenever you are doing some kind of cryptography like RSA, you will run GCD like all the time actually. So that's actually like very helpful subroutine for RSA. Other than that, like other than like cryptography based stuff like elliptic curves and RSA, blah 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 blah, I don't have like some kind of great application of GCD. Like one good thing is that like this is again like a simple algorithm, right? Like if you want to explain what an algorithm is, you can kind of this is like one of the things that you can start with. It's like one for loop. It's kind of clear it has to end somewhere, and
And you can implement it recursively, which
I'm
establishing is my thing now, apparently.
Yeah, it's just a jail time. Just jail time straight up if you do that. Sending the FBI to your home. This feels like barely an algorithm. It just feels like a... I don't know.
To be masterpiece tier. I mean, the fact that
Okay.
it existed for more than 2000 years is crazy, right? And it's not really that obvious, I think.
I mean, you can say the same
No,
thing
no,
about
no.
Bogosort, right?
True.
What?
I think
Which
it's
part?
barely. I think it's barely great. I wouldn't put it masterpiece.
Barely great. Okay.
Barely.
Barely great. We have a lot of stuff in great, so I will put it at like top solid.
What? Are you crazy?
Yeah.
What?
I'm happy.
You think it's
No.
great?
Yeah.
Okay,
Really?
all right.
Okay. Okay, let me put it here. Whew. Fast inverse square root. So this is an algorithm that computes, like, you know, on if you get input x, it computes 1 over root of x. And
Or maybe
the
you
whole
want to
shtick,
show the source code?
yeah, the whole shtick of this algorithm is
With
that
the
it's
comments as
horrible.
well.
Yeah.
Yeah.
So this is the algorithm for computing 1 over root of x, and it became famous because it's just like famously unreadable, or like, you know, hard to understand what the hell's happening there.
It's some like.
Oh, this actually reminds me that like at some point we wanted to make a video about all the bit tricks, like, you know, weird bit tricks and then even weirder bit tricks.
Oh, yeah.
And
Did
this is
we?
actually like one of them. Actually, we also kind of like partially covered some of this in our last video because we have been talking about this float format and so on. So like the reason why this bit trick works is that, like, you know, if you do some like weird bit shifts in float format, it actually corresponds to some like nice arithmetics.
Yeah, and the what the fuck
Okay.
comment is apparently what they actually had in the source code, is what it says.
Yeah. I mean, this is like the only reason why we have this algorithm here. I would say.
Pretty much.
Actually, like you know, as far as I understand, like there has been a period of few years when this was like the state of the art, but like now you will have like a CPU instruction that does this thing much faster.
Yeah.
So yeah, this is
But
like stuff
like
from
the
historical
urban
books.
legend around it, I feel like I think everybody knows about this and everybody knows about the comment. It's like this in and of itself is like, even though it's not used anymore, and like the actual implementation is some like Newton method stuff where it's like trying to approximate the square root, right? Is something like that? Like the first operation like gets close to the number and then it's like the Newton method, right? I don't know if I know this. Yeah, but like the urban myth around it is like so powerful that I feel like it should be like at least masterpiece, because it's like fast
At
inverse
least
square root.
masterpiece.
Yeah, like
No,
at least
you're
master, not
looking at
legendary, but
legendary
like
now.
no, this is
Master.
legend. Yeah,
Oh,
yeah.
sorry, masterpiece.
I
see,
feel I
I
would
see.
put it there, but I don't know about you guys.
Yeah, so I kind of feel split about this one because like you know, usually I would think like, you know, it's either orange or yellow or something like that, but this one is like either red or blue, right?
Yeah.
So what do you think?
I don't know.
To me,
Yeah, I think
Back me up
masterpiece.
Yeah,
Sorry.
masterpiece.
Okay.
Masterpiece.
I like it. I like it.
Okay.
Yeah,
I
yeah.
think it's a fair judgment.
Okay, but it can't be better than back propagation, right? I mean, we can't be kidding ourselves, so let's put it here.
Fair.
Okay, FFT. Okay, so
Legendary.
Yeah, I think
yeah,
that's
so
it. Yeah,
FFT is like this.
we agree.
Yeah.
No more things
Yeah,
need to be
I
said.
still have to
That's
say
pretty
what this
much it.
algorithm is, but I still have to say what this algorithm is, and then we can go on, right? Yeah, so this algorithm computes Fourier transform pretty much close to in linear time, and this has all kinds of practical practical consequences, like when you are processing some audio or something like that. Also, all kinds of like cool theoretical consequences, like that you can multiply two long numbers in close to linear time. And you know, like if this wasn't enough, then like there is even like quantum Fourier transform, with which you can actually, like, you know, factor people in polynomial time. So like, you know, the applications just go on, and just like this kind of like beauty and the fact that it kind of feels like this should not be possible. I think all of this basically, like, you know, basically we can decide like where in the legendary tier it is, but I think
I'm not as excited about it, I guess. Like, how often do you use FFT? Yeah, but fair enough. I mean, I feel like it's more like a piece of math than an algorithm, right?
Yeah.
maybe from that perspective.
Well, like definitely we have some kind of bias here, right?
Yeah.
If we are talking about some kind of pure elegance, I would really put it at the very top. If we are talking about some kind of applications, then like sure, like Diffie-Hellman is probably run more often, but then we can start talking about like I don't know for loops, right? I guess like for loops are being run much more often than Diffie-Hellman.
Yeah, I don't know.
But like,
I guess
are they legendary?
I guess it's because it's not this sort of like combinatorial algorithm of the, yeah, I don't know, like binary search tree or dynamic programming or the classic algorithm. It's more like we're going to figure out the equations and then we're going to do it. Like it's a very confusing. I don't know. But that's my aesthetic argument. But I see I'm in the minority here.
Okay, let's go on. Gradient descent. So gradient descent is this algorithm where you have some function, you try to optimize it. So you kind of have like a point, you have some kind of point on some surface. You try to find smaller and smaller points on that surface. And you do it by doing steps. Basically, you simulate physics, right? If you kind of put a ball on the surface, then the ball would be kind of rolling down in the direction of the gradient. And you can pretty much simulate it on computer. In every step, you compute the gradient. You shift the ball along the gradient a little bit, and you just run this until you are hopefully close to some kind of good point. You will get close to some kind of local minimum, which is not necessarily the global one, but in practice, you can do some pretty wild stuff with this algorithm. Like for example,
Legendary.
pretty much every modern machine learning is based on gradient descent. Okay, you are saying legendary?
Yeah. Although, like, I guess you could make the same argument for backpropagation, but it's just like what powers all of machine learning since a few decades now. Or like at least since 2012, like the deep learning era. It works like surprisingly well, right? Because it's like, oh, it doesn't reach the global optimum, but then there's different things like, oh, it actually turns out that like it works in places where it theoretically shouldn't. Like, oh, there are many optima, and some of them are really bad. Actually, like would lead to like bad models. But gradient descent somehow tends to find optima that are really good for not just the training data, but then also like generalize well.
Yeah, I cannot disagree. Yeah, I would actually personally put backprop here just after gradient descent, but I can also make it like I can also live with this one. What about you guys, Tom, Risha? What's your opinion on this?
Yeah, I agree with this, how it's now.
Okay. Graham scan. Okay. Graham scan is an algorithm where we start with a bunch of points in 2D and we find their convex hull. So this red thing is already most of the convex hull of the points. If we kind of edit a few more red edges here, we would get the full convex hull of the points. And the algorithm is that, well, you pretty much kind of just do it, I guess. You kind of like run around and yeah, do it. Why is it useful? I have no idea. Maybe in some graphics, I don't know.
Wait, but this is actually not like the, as I'm reading it, this is not like the algorithm that I personally have been taught for convex hulls, no? Like I know the algorithm that computes kind of the upper half and the lower half, and then kind of.
I think that Graham scan is maybe you know, there are definitely more ways to solve this. It feels that it's the kind of problem where like all the ways all the roads lead to Rome, right? But I kind of feel that I kind of saw an animated GIF with this algorithm. It kind of felt like this algorithm you probably know from undergrad. But Graham's can doesn't do 2 halves, but probably just 1. I don't know.
That feels kind of more elegant in some way.
Mm-hmm.
Maybe, yeah.
It's very cool. Wait, I hope you have like local storage, because I think you. Okay,
Oh my
Okay.
god, nice.
I'm impressed.
I would put this very low because I've never heard of this.
Uh-huh.
Yeah,
I don't know. It can't be worse than Bubble Sort, right?
yeah.
But
Like
what's your problem with bubble sort? It's a nice algorithm that works well on almost sorted data. It's nice to implement. Oh my god. Actual
I think
hater.
it's fun. It's a fun algorithm, but yeah, probably not that useful.
Yeah.
So what do you think about this?
I like this. Oh, you really
Yep,
like you
okay.
really hate bubble sort.
Okay, hash tables. So hash table is a data structure that people use all the time. Basically, you have to store maybe a bunch of names or something like that. So you just pick your favorite hash function, you hash those names or strings or anything into numbers, and that's it. You just store it at the appropriate position in your hash table. And it works incredibly well. It's like really fast. If you choose the hash function, you will not get that many collisions. It will basically behave as if you were kind of storing it at random positions. Yeah, this is incredibly quick and people use it all the time. There's also a lot of kind of nice theory behind it in some sense.
I feel this is kind of similar to like binary search trees. Like I like it a lot, but like practically to implement, and there are like a lot of cool stuff like cuckoo hashing or like AKS hashing or something like that. But then also like if you actually want to implement it and implement it fast, like I don't know, it feels annoying.
Yeah, I kind of feel like it can be worse than binary search trees because hash tables are actually like useful, right?
Yeah, but like on
mean,
the other hand, like what's the first thing when you're learning a new language? I feel like the first thing I learn, okay, how do I do like arrays and stuff? And the second is like, okay, I want to do dictionaries now. So I want to do a hash table. Like how like what do I learn now? So it's like it's one of the first things that you kind of need to know to be able to write something at least modestly complex, and it's not just like array work. So I would rate that, like I would give that quite a few points higher for this reason exactly.
Masterpiece.
Yeah, I
Yeah,
agree. It's like feels like so for example, you have JSON, right? And that's just like arrays and hash tables. So it's somehow like very fundamental.
Yeah, exactly. Yeah. I feel it's just like much more fundamental than binary search trees. It just can't go below. It's like much more useful in some sense, I think.
Yeah.
Okay. Heaps. Okay, so heap is something like a binary search tree, but in binary search tree, somehow if you go left, you go down. If you go right, you go up. But in heaps, you just always go down. And this is good if you want to store the data. Like if you only care about extracting the maximum, in this case, or in the opposite case, if you only care about extracting the minimum, then heaps are somehow easier to implement than full binary search trees. They are probably a bit faster, but also not so much.
I think it should be
yeah,
exactly
what
in
do
the
you think?
middle of heap sort and wait, no, sorry, in the middle of wait, we already have what? We have heap sort, no? Oh no, sorry, radix. Okay, I'm
I
done.
mean, heap.
Ignore me.
This is the same thing. Like heap sort. This is like one algorithm.
Yeah. Okay. Yep.
I don't know. I would put it like here, solid.
Yeah.
Yeah.
Or is it garbage actually?
No. Heaps are cool.
No. Okay.
No.
But the fact that you have to remember which way to bubble up to like ensure the reasonable complexity that's a minus because I never remember it.
Okay. So
Yeah,
let me put it in the solids.
Yeah, I might be biased. I would put it like right next to binary search trees, but yeah, I am fine with that.
I agree.
Yeah. Okay. K-means. So this is a machine learning algorithm. One of the kind of good old machine learning algorithms. You have a lot of data points. You try to find some clusters, and K-means is the way to do it. it's kind of like an iterative algorithm. You start with some centers and clusters around them, and then like iteratively you try to improve until you find some local optimum. I guess some kind of generalization of this is called EM algorithm, so we could also talk about EM algorithm. So what do you think?
It's kind of hard to compare it to all the other ones, right? Since it's like
Yeah.
This is kind of an embarrassing question, but did you guys actually know k-means? Like, I actually learned about its existence like quite recently. I think like nobody ever taught it to me like in undergrad.
Same. I feel
Really?
like for statistics, I think you kind of need to know this, but I don't really. This was not in my studies either, so it's like, I don't know.
Really? I actually thought that this is like, in some kind of ML 101 course, you will either start with linear regression or k-means, right? Like you will start with something like this.
it is an ML classic, yeah.
Yeah.
It's like to me, it's also actually important if you are talking about something like k-means, like literally this one problem, or if we are talking about like this more generic EM algorithm, because this more generic EM algorithm, it's almost like talking about gradient descent, right? Or talking about these like very generic ideas of just like iteratively improve until you converge to something good that kind of work much better than like what we should hope for.
Yeah.
I would put it low.
Really? Like
I don't have strong feelings about k-means.
Yeah, okay. So then let me put it to the top of solid tier. Okay.
Yeah.
Strassen algorithm. Okay, so Strassen algorithm, that's like a fast way of multiplying two matrices. So if you multiply two matrices, each one is n times n, then like clearly you can't do it faster than n cube time, right? Because each matrix has n squared numbers, and to calculate one cell of the new matrix, you need to do like n operations. So like you clearly have to do n cube operations. You clearly can't do better, except you actually can with Strassen's algorithm, which is incredibly surprising if you ask me. Easier variant of it is called Karatsuba's multiplication algorithm. You can multiply two numbers faster than n squared with it. And actually some variants of this are also practical because if you try to, like currently people are optimizing GPUs like as much as they can, right? And actually what happens on GPUs is multiplying matrices. So somehow similar techniques like these tensor decompositions that you will use in Strassen's algorithm, you will actually also use to optimize your GPUs. Although in that case, you will kind of keep the complexity n cube. You will just improve the constants. But still, you are kind of using similar techniques to speed up some like really important computations.
By the way, I think I've heard that like people don't use Strassen's algorithm in practice not because like the constant is so big, but because like of numerical stability issues. Like, do you know if that's true and if there are like variants that like avoid this?
Yeah, that's totally true. Like the basic Strassen algorithm, I think you would basically never use it in practice because it's just like numerically incredibly like unstable. You would probably use it like if it was like competitive programming and you just wanted to know the answer modulo 1 billion plus 7, then like you don't care. You can use Strassen's algorithm. It will probably do just fine. In practice, you just never use it because of numerical instability. This is also why I mentioned the fact that like like Strassen algorithm is just like for now I think it's still like theoretical stuff. It will probably be implemented in some kind of like Mathematica software, but you will probably mostly don't run it. But like the ideas that are behind it, like these tensor decompositions, you will actually use to optimize your GPUs.
Yeah, it feels kind of like Euclid's algorithm in a sense that it's like more math slash like a party trick slash like an optimization thing rather than an algorithm. So I'd be like, I don't know, I wouldn't rate it too high, like if I were to compare it to other algorithms, but yeah, I don't know.
So what do you think?
Like borderline garbage? I don't know.
Like so far?
Garbage.
Yeah, I'm
I mean,
I'm
can't be
gonna
behind
agree.
bubble sort. I mean,
Maybe
What
it's
is
time
with
to.
you?
No.
Maybe it's
I
time to
think-
move bubble sort into garbage. Honestly, I don't know.
Yeah.
No,
I feel like we get stuff in
leave
garbage
it.
too.
No, my
I-
precious.
I also don't like it because it's like, oh, here are like 7 equations and this is why it works, but it's like, okay, I guess.
Yeah, same. I think this is fair.
But do you know? Do you know like the like you have these like algorithms that improve like this exponent like in n to the 2 point something something? Like, do they use basically the same trick but like more and more improved? Or like, do you
I
know
think
how
you
they
can
work?
think of it. Yeah, I think you can think of it this way that it's like some like this trick on steroids. Like I think that it's like legit to think of them this way. Yeah.
Yep. Okay, sounds good. Onward.
So like definitely like theoretically it's much more interesting than practically, except like as I said, like you can actually it's actually kind of important like if you are optimizing GPUs, I think.
Oh,
Okay,
random
let's go
question.
on.
We need to rank fast inverse squared question. That one is actually legendary too. We have that one already. Oh, sorry, masterpiece. So yeah, we have the important algorithms. Do not worry.
Yeah.
Okay.
Okay, KMP/Aho-Korasik. So basically, Aho-Korasik.
Garbage. Okay, you don't need it. Okay.
No.
Okay.
Hot garbage.
Go on,
Should I
KMP.
read it? Okay, so this algorithm solves the following task, right? So you have like a long file, and you want to find occurrences of some words in it, right? You have maybe like a list of 100 words that you want to find in that file, and how you do it is that, or how Aho-Korasik algorithm does it, is that builds this thing called automaton, this kind of like funny little graph from your words. And then the Aho-Korasik algorithm just kind of iterates over the long file. And as it iterates, it's kind of like jumping inside this automaton, jumping from a node to a new node.
Sorry,
and so
1
on.
second. There is some noise coming from Risha.
It's not heard in the stream, but yeah, it's
Oh,
Risha.
okay,
It's okay.
sorry.
Okay.
Yeah.
Anyway, the algorithm builds an automaton, and then it iterates over the string, over the long string, and finds the occurrences of all the words. And KMP, that's basically like poor man's Aho-Korasik. You just have like automaton for one word. Okay, so Tom, please tell us
Garbage. Any
this
algorithm that needs to bootstrap itself, like KMP, is garbage. Why do you need help? What is this? Baby o'clock? Garbage tier.
That's the Sigma grind set, no? Like you bootstrap, you start small.
Like I still have I have PTSD from trying to explain this algorithm at the summer camp that I go to, because it's like I understand why it works, but trying to explain the trick of how you cut the first character and then you kind of run the algorithm on itself to build the automaton is I'm just bad at explaining things. So this is just me speaking from from PTSD, and so it's just like maybe a bit unfounded, but I don't like it. It's just I would rather use the hashing version, like was Rabin-Carb? No, how do you call it? Is it Rabin-Carb?
I think.
Whatever, the one
maybe
that just does
primality
hashing,
one.
which is practically going to be faster anyway, so I don't have to No, that's primality, I think.
Okay.
Yeah, it should be
you're
Rabin-Carb.
right.
Yeah.
Rabin-Carb.
So that one, because that one, I don't know. Maybe you guys decide because I'm just a hater.
Oh, garbage is fair.
Okay, good.
I would put it as solid, but okay.
At least it is solid garbage, right?
It is solid garbage. It is solid garbage, right?
Garbage
On the
plus.
border.
Okay, merge sort, like very OG algorithm. You want to sort a sequence, so you split it into 2 parts. You sort each one recursively, then you merge them. That's it. Von Neumann came up with this algorithm when he wanted to do something fast. I think people still use it in practice because there are still these things like tim sort, which people use in Python and Java apparently. And this is basically like merge sort with a few optimizations on top of it. I think it also has like all kinds of good properties, like you can run it in place and so on. I'm not sure how often people use it in practice currently, though.
Wait, in place, that's this like very cursed thing, no? It's like square root of n something something.
I actually don't know. Yeah, I don't know. But also, like, you know, if you want to do it like, you know, cache in some kind of cache oblivious way, I think that, like, you know, merge sorts should be relatively like reasonable to implement in some kind of cache oblivious way. I'm not sure if like, you know, it's so easy for quicksort.
It's like I like it.
Okay, so like better than solid, like it's great.
Mm-hmm.
I mean,
Yeah, like
I would not
maybe
say
like
it's masterpiece, right?
no, maybe like lower grade, yeah.
Like here.
Because we're
Yep.
gonna have quicksort, and quicksort is better.
Yeah.
Yes.
Arguably.
Oh, speaking of quicksort. Okay. So again, you want to sort an array. So what you do is that you pick random pivot, like this element here, and then you just go through your sequence. All the stuff that's higher you put to the right of the pivot. All the stuff that's lower you put to the left of the pivot, and you continue. You recurse to the left, you recurse to the right, and you're done. Very fast algorithm in practice. I think it's like one of the fastest ones. Except, you know, we have this whole video that says that it is not really. But apart from that, it's really one of the fastest algorithms. It plays very well with caches. It plays very well with, like, you know, how the actual hardware looks like. So yeah, I think this is pretty strong algorithm. Like, it should be higher than merge sort, right?
Yeah.
So I would maybe consider putting it into masterpiece class.
Yeah.
Yeah.
Sounds good.
Yeah. Okay. So how high?
Like
Maybe
second.
there. Yeah.
Whatever.
Yeah.
Okay.
Sounds
okay.
good.
By the way, what is this thing doing here?
Yeah, that's true. What is it doing there? It should be legendary. True.
No!
No, go back. No! Oh my god.
Okay.
It should be collaborative so we can also change it.
Okay. Ray tracing. Okay. So you want to draw beautiful pictures like this one, where you have like all kinds of shadows and you have like a reflection of reflection of reflection. So what you do is that, like, you have to trace all the rays that are in the picture, right? And like naively, this would be like really complicated, because if you have some source of light and you would start kind of generating kind of like a photons going from that source of light and like starts like bumping around, and like most of the photons will actually end up, you know, at some completely different place than the camera, right? So actually, like, one of the tricks that people use in ray tracing is that they actually go backwards. They actually start from the eye. They kind of start the ray going from the eye to the screen, and then they actually like bounce it backwards until, you know, they hit some object, and then there are like, you know, 5 different things that they are doing to capture all kinds of interesting physics, like, you know, refraction and reflection and all kinds of stuff. So,
I'd say garbage,
yeah,
because
it's fun.
it's not an algorithm, it's a concept. Like
Yeah, that's right. But like, you know, all like, is gradient descent algorithm or is it concept, right?
well, you got me there. Okay, fair enough. Yeah, I don't know, maybe not garbage, but like
I mean, it's definitely very solid, I would say.
like there it's just like there's so much things going into this, like watching what's the guy's name, Sebastian I don't know how to pronounce the second name, Sebastian Leash, the guy who does like the
I don't know.
whatever he does videos that
Sebastian
are like
Lag.
yeah. So he had like I think 3 videos on raycasting, and there's like so much stuff when you say raycasting that it's I don't know, just hard to rate, because it's like the concept of raycasting versus, you know.
Yeah, totally agree.
Ray tracing is like the bubble sort of rendering in the comments.
True. True, actually. Masterpiece.
I mean, we can have it like the solidest
Let's-
solid algorithm
sure.
or something like that. Yeah.
Sea of
Okay,
Eratosthenes.
not many more remaining. So now we have Sieve of Eratosthenes, another OG algorithm. So you want to find all the primes smaller than n. Don't ask me why you would want to do this thing, but yeah, you want to do this, and you just do it. Okay, so that's the algorithm. Yeah, what do you think?
I love that its time complexity is n log n, and I love the analysis.
Okay,
I know it's super impractical, and the analysis, like who should care, but I love it.
Okay, yeah,
I think it's cool,
that's
yeah.
fair. Actually,
It's
there is
like,
like this fun fact that like you can actually implement this thing in sublinear time, because number of primes is not n, number of primes is like
Ooh.
n over log n. So actually, you know, if the task is to like list all the primes smaller than n, you can actually do some tricks and do it in times like little o of n.
mean,
But
it's really-
that's not Eratosthenes sieve. That's called like veal sieve, or like, you know, that's
There's
like
like more
other-
advanced
other
sieve
sieves.
stuff, right?
Yeah, yeah.
Also, plus points for being extremely old.
True,
I
true,
guess,
true, true.
yeah.
It should go next to the Euclid algorithm, no?
Yeah.
I would just put it there.
Yeah. And like
Yeah,
both of them should be
it
garbage, or like.
no, no, it belongs to it. It's
No.
I once read.
But like, you know, Euclid's algorithm, you can actually. Oh no.
Uh-oh.
oh, the
We
vibe
reached
is
the limits
strong
of
within
vibe
this
coding.
one.
But you know, like Euclid's algorithm, I can at least like argue like why would you care about it, right? Because RSA. But like sieve of Eratosthenes, like why?
Yeah,
why
it's
would,
true,
like,
it's true.
Anybody care about like listing primes? Smaller
Yeah, it's
than
fair, it's
n?
fair. I would probably put it lower as well.
Fair enough. But it's cool.
I mean, it's not even solid, right?
Oh!
No, what?
Huh?
No.
Okay,
100%
we're
disagree.
going a bit farther, Chief. I would put it back up. Yeah, solid's
Okay.
good. Solid's good. Yeah.
Simplex
Fine.
method. What do you think, Tom?
But why is Bubble Sword the last? He just keeps shifting it down when I'm not looking. Put it back.
No, Tom. You know, I am bubbling. I am running your favorite algorithm.
Oh no. Okay, well.
Yeah. So simplex algorithm, another amazing algorithm. So you know,
S
you
tier
want
masterpiece,
to solve.
because I had a video on that. S tier, the best one.
Yeah. So let me explain it like in a minute, right? If you want to explain it in 15 minutes, like you have to watch this video. Yeah, but like, you know, like linear programming, that's like a very generic way of solving problems. You just formulate your problem as having a bunch of numbers, like a bunch of variables, bunch of constraints that are saying stuff like, you know, sum these two things, it has to be at most 42, and sum those two things, it has to be at least 60, and so on. And then you want to like solve all of those constraints. And the simplex algorithm is just like a very fast way of doing it. And like, it's actually very geometrical, because if you have all of those linear constraints, you can just like literally imagine that what you are dealing with is some kind of object like this. It's just like some kind of polytope, I guess. And once you find like at least one thing on the polytope, like once you find at least like one corner on it, then solving the problem, like in linear programming, amounts to basically finding the lowest point. Finding the point that is lowest, similar to how in, you know, gradient descent, we also want to solve the problem of basically finding the lowest point. And the simplex method literally just like walks along the polytope and always goes down. It's just like, you know, very physical thing, right? It's just like if you put a bead on top of polytope and you let it slide, then basically it would do something like this. It would be basically one of the possible implementations of the simplex method. And in practice, incredibly fast. In theory, it's like a complex topic, but we also have some kind of justification that it's actually fast.
You mean like the smooth complexity something?
Exactly. So there are some
What's that?
counterexamples, something called Minty-Cube, whatever, where this algorithm actually takes exponential time. But then again, we understand that like if you take like any polytope and you
depends. No.
Depends on the
more
selection rule, right?
exactly. It's kind of like more complicated topic, because simplex method is like a meta algorithm. You can decide in every vertex like which edge you take. You kind of have to take something that goes down, but oftentimes there are more edges that go down. So yeah, like as far as I'm like pretty sure that like for every reasonable rule there will be some counterexample. Possibly there may be some kind of amazing rule which is polynomial. I don't think this is ruled out.
But it's not used
Although
in practice
maybe even
because
that one is ruled out.
Yeah.
I'm actually not even sure. I wouldn't be surprised if even that was like ruled out. That like any reasonable rule can't work. But whatever. This is kind of like complicated topic. But like regardless, where should we put it?
Like I would put it in masterpiece. Like if we were talking about like linear programming as a whole, that would be legendary for me because it's you can solve so many problems, and it's like it was a big surprise that it's like polynomially solvable, right? With like the ellipsoid algorithm or something.
Yeah.
Yeah.
Definitely, I agree.
Yeah, in general, I kind of feel that like some kind of like optimization in general is like very masterpieces / legendary topic, and like this optimization can involve like gradient descent and simplex method and like interior point methods. It all feels like very similar, right? You are doing some relatively natural algorithms, like walking along some kind of gradient, and it just like works so well. I mean, it can't be worse than fast inverse square root, right?
Debatable.
I think this is good. Last one?
Transformers.
Last one, transformers. Yeah, so this is a bit controversial whether this is even an algorithm. It's more like architecture, I guess.
It's model.
Like, does it stand for this concrete architecture, or does it stand for neural nets in general? I don't know. We can debate it. But anyway, amazing architecture. Works very well, clearly, right?
I mean, it should like by definition be legendary because it generated the thing that we're right now ranking algorithms on. So like by definition, you have to rank this legendary, otherwise.
You are making good point. Yeah, I think like this pretty much has to be legendary. There's just like one thing where I am not like completely like that I'm like not buying like 100%. It's like possible that like in a few years we will find out that actually there's like not that much like magic in transformers or something like that. It's just like an architecture that like people found out was good, and I'm not sure like how many other architectures people are trying currently, right? Because even if you find like a good architecture, it's like so hard to like push it further, because even if you have a good idea, you have to like put all the constants at the right place. You have to scale it. You have to do like so much work to test that it scales well, that it's actually not clear to me if like transformers are like really like the great idea that like solved AI, or if it is more like that if people didn't came up with transformers, maybe just like some kind of RNNs on steroids with some little tweaks would work as well, and maybe like the scaling laws would work like exactly the same, right? I don't know.
There's the argument of the hardware lottery that basically transformers / like the bitter lesson that transformers are not necessarily like the best model, right? But they're just very efficient, and other things might scale as well with like the number of training steps that you do. But because we have GPUs that can do matrix multiplications quickly, and because the training step you don't have the autoregressive component like you do have in RNNs, then you can train it more efficiently. It doesn't necessarily mean it's like the best. To me, it's garbage because it's not an algorithm. I don't think it's an algorithm.
I mean,
legendary
architecture, but garbage algorithm in my view.
I don't know.
We have data structures there, Václav, right? So like it's binary search tree algorithm, not really, right?
Like the whole thing's a mess. So at this point, we're too far to resolve any of this. So
yeah,
I don't know.
Fair enough.
So maybe bump it down masterpiece. I don't know. I think this is reasonable. Like I would.
I mean, maybe we should do this one, as a part of our.
True. Subtle foreshadowing for later.
Of the next
video.
Right?
True.
Yeah. That's fair.
Nice.
Cool.
Nice. I'm happy. Okay, I will save my rankings.
Wait, does that work?
That do?
What the?
No, it just creates a pop-up and doesn't do anything else.
Okay.
Oh,
Actually,
okay.
some people apparently already voted. I see
Wait,
like
it
4
has a
votes here.
database?
I mean, yeah, so
I
surprised.
thought
Like,
it's a local thing. What?
have you been vibe coding like the last year, or like, you know?
Oh my god, okay. I am getting the credentials to access it. 1 second. Did you leave the default password? Oh no, okay. Kidding. Nice, awesome.
Take a screenshot as well. I don't believe that this will work.
It's just not even the database, it's just like randomly generated values for the votes to do
No.
input your implementation here later.
No, actually, was it some of you guys or was it the viewers?
I didn't
Not
say
me,
it, no.
so I guess
Okay, so I
viewers.
guess we had like some viewers. It
Nice.
seems that people like hash tables, FFT,
Nice.
quicksort, and this
Of course.
crap. Okay.
True.
Yeah. Anyway, like if you are watching this, then like please submit your ranking too, and you know at the end of the Q&A we can look at it again, right?
Mm-hmm.
Okay.
Sounds good.
That's it from me. So let's go to the
Nice.
next phase, right?
Maybe do we want to take a break for like a bit? I think.
Yeah, maybe come back at 15.
Yep, sounds good. Wonderful. So let's take a short break and we will be back very soon. And we are back. Are we back though? Looks like we are. Okay, so for the next segment, as we wrote in the YouTube chat, we're going to be doing a competitive bot game where every single member will program a bot that will fight the others. And so I'm gonna share my screen now. Can you guys see it? If you don't, just yell. Otherwise, I'll just show my thing.
Yeah, I see this.
And so, yeah, okay, wonderful. So it's called Chromatic Warfare. Very inventive because it's played on a graph. And the point is that I think I'll just start a game and show you how that works. So I'm gonna connect with my bot. As you can see, this is me, this is Tom, and there's some 3 other bots that are placed on the graph. So you are spawned on the graph in some particular vertex. I'm gonna increase the size of the graph maybe, so it's, no. It's fine like this. So you're spawned in a vertex, and you can see that you are right here. There is 1 unit in this particular vertex, and the other vertices have weight 1. And the point of the game is to, I'm gonna, I guess, start it, is to combat others, where you are sending commands from the vertices you control to expand onto other vertices. And as the game progresses, your point is to control as much of the graph as is possible. So you can see that right now, Hardbot is kicking everybody's, well, something, because, I mean, it's a hard bot, so it kind of makes sense. As you can see, it won, with Tom being second, EasyBot being third, MediumBot being fourth. And so I can maybe show the, I guess maybe I can show it again and explain the rules slightly. I don't have anything particular for this, but I will share a link to the game, to the YouTube chat, so you can also play along. There you go, and I'm gonna join again. So again, the point is that in each round, first you declare the moves that you would like to do. So for example, I'm red, so I'm starting in this bottom left vertex, and I can issue command of this vertex moving the units to a neighboring vertex. So let's say I move to this one. And so what would happen is initially you issue commands. So all the bots and all the players issue commands. Then these commands get executed, which means that the units are sent from the particular vertex onto the vertices that are specified. So for example, I would send here to expand. And after this is resolved, so after the units arrive, the vertex either becomes controlled by you or by other people or stuff like this. And there's the second phase of the particular round where the units for the particular vertex get incremented by its weight. So as you can see, I'm gonna start it perhaps with a slower time so you can see. I'm gonna do 5.0. Let's update the settings. Oh, it just kicked me out. Oops, all because I didn't do any actions for a while. So I'm gonna do a slower time so you can, I guess, better see what's happening. Let's do something like with 10. Okay, so initially commands are sent. So yeah, you can see it's very slow. Then the vertices are being controlled, and then the units are added onto the vertices. As you can see, the animations are now pretty slow, but this is kind of what's happening. And I think it's better if you ask questions at this point rather than me explaining it more, because I don't know if it makes sense by now what the goal is. But if not, I think it's better if you ask and I explain.
So, how is it evaluated? Like, who gets the vertex in the end? Like, the one with the maximum amount of points gets the vertex, and like.
So yeah, the combat rules are slightly, well, not complicated. It's probabilistic. So like if you have a particular vertex where it's not controlled and you are sending units and another person's sending units, then it's probabilistic who gets the vertex. So if you send 5, he sends 2.5, then it's twice as likely that you're gonna get it instead of the other person. And this holds for any number of other players, because otherwise it would be a bit messy. So if like there's 3 players who are sending all their units together to a particular vertex, then the one that gets the lucky dice, I guess, gets the vertex. That's the point.
But that's only for vertices Okay, so what if there's like 5 blue guys somewhere, and then yellow and green both send 10?
So what would happen is that the defenders would get overwhelmed because there's 10 attackers and you said like 6 defenders. And so that would mean that this vertex would lose control, the player would lose control, and then the other again roll probabilistically based on how many units they send.
And those are decremented by 5, both of them then, or
Yeah,
like
the
half of that?
final tally will be something like you take the defenders, and if there's more attackers, then okay, this is more of an implementation detail, but what will happen is that all of the defenders will die, and the attackers will then roll against each other, and whoever wins, like the winning group the defenders will subtract from the winning group, and essentially like
Okay.
the remaining
And
pieces will remain there. Yeah, pretty
and the
much.
one who doesn't win loses the whole stack.
Yes, yeah.
Okay.
So like in cases like these, just think of it as like combat where you have defenders and attackers, and if you can overwhelm a particular vertex, then the winners will be decided probabilistically if there's like multiple people sending units.
Okay.
Yeah, pretty much. Okay. Any other questions? I can maybe show the game again to kind of see, maybe to showcase more things on it because it's kind of a lot. So let me just start it. Yeah. Okay. Like so, for example, here. Sorry.
No, sorry. Go ahead.
Yeah. So for example, here, as you can see that, yeah, these will be sent here. This will become controlled, and then the second phase will get incremented by the weight of the vertex. So you're essentially, yeah, sending the commands based on the vertices you control and the ones that you want to become controlled. And I can, I guess, show the code because that make it a bit more sensible what's happening here. So if you click on this link, how can I play? You get sent here, which is a simple snippet that you can download and you can play. So you guys should try to do that. If that works, that would be great. It just uses Python's WebSockets. So you pip install WebSockets, or if you have some other management for pip, you install it however you like. Then you just get the bot library. So this would be the one that communicates with the server. And the simple bot implementation is very easy. So I maybe just explain it now. If you want to implement a bot, you have to inherit the GameBot class. And all you need to do for the bot to work is to implement the plain turn method. And so for me, this is a simple bot. So all it does is that it looks at the vertices that are on the front line. So for example, if I look back here, then frontline vertices would be those that are like kind of on the border. So for example, for blue, it would be the vertices like right here. I mean, that's all the vertices, but for yellow, maybe it's more interesting because these wouldn't be frontline. These are not like touching some vertices that are.
Actually, the
Sorry?
blue 6 is not on the front line, right?
Yeah, right, yeah, sorry. The blue 6 is not on the front line. And so what this does is just expands to neutral vertices. So for all vertices on the front line, it looks at the weakest neutral neighbor. So these methods are documented back down here, but you can just copy this and start with a simple bot. And so you get the weakest unit. And if you can capture it, so if right now you can send units such that this vertex will become captured, then you just send all the units from that particular vertex onto the nearby neutral one. And that's the command that you add. And at the end, you just return all commands. So this easy bot, essentially what it does is that it just, for all the frontline vertices, looks where it can expand to neutral vertices, and it just does that. And so that's pretty much like the simplest form of bot that you can think of. And yeah.
Sorry, technical thing. The video ninja thing is a black screen for me now, so I'll just refresh.
Oh, is it?
No, I mean the whole site is not loading for me. I'll just refresh it.
Sounds good. You should just drop a bit. That's okay. Nice. Risha, Vashek, does that make sense? Or is it
Yeah, kind of.
Yeah, let's try it.
Okay, yeah, I mean, so I think the point now is that this snippet, what it does is that when you run this code, it's going to generate a random game ID, and then it's going to show you the URL to where to connect. So right now, if I were to run this code, I would get something like you can view the game at whatever, game ID would be this, and then you can play the game against the bots. But if you want to actually play against each other, you would say that the game ID is default, which is this one at cw.slama.dev, and then we can start the game together without bots. So if you want to just try to do that right now, then maybe we can. If you take this snippet and modify it such that just this is default instead of just generate game ID, and you remove the bots argument from this, then you just connect as a regular player. So maybe if you want to try to do that, I'm gonna do that on my end. And if anybody in the chat wants to do that as well, you guys can as well. It should work. You just remove the, yeah, I'm gonna maybe show it. If I take this and I modify it such that the game ID is default and bot.run is just this, and then I connect to, and I say them Tom, then I should be, yep, I'm connected here. So right now I'm here, I've got one unit, and that's that.
Mm-hmm.
What's the fancy one?
What was the last thing?
Yep.
Like, how do you remove the easy? How do you remove the default bots?
At the end, just remove the argument. Yeah, just do bot.run.
Okay.
So I'm gonna see if somebody else connects, and then we can play.
For me, it works. I'm just.
There you go. Nice.
Why am I a alien? What?
It's a bug. It's a bug. Don't worry about it. Oh no, you started the game, I think. Yep.
An alien.
Did you start the game?
I didn't.
Somebody started the game. That's fine. I'm gonna reset it.
Not intentionally.
And I'm gonna change the return duration to 1 second, and then we can just start the game. And as you can see, it works. Your bot should be sending the commands. It should be printing some stuff. Is it?
Yes.
Nice. So we're just playing now. And now the game has concluded, and you won. God damn it. Nice. Yeah, and so I'm gonna I can reset it, and if you connect again, we can maybe try it as Alt4. And maybe if somebody in the chat wants to also connect, that's fine.
I mean, I don't really have anything I've coded yet, right?
You can just try the simple robot so we know that like it connects.
Okay, sure.
And then we can maybe take some time to try to do some more advanced strategy, because right now the bots aren't really capturing anything. So right now the bots just expand to the neutral. Vasek, you did remove the bot line, so now we have 5 bots, but that's fine.
What do you mean, remove the bot line?
If you connect with the script, you need to remove the
bot.run.
Bot.run. If you just well, I mean that's fine. Right now there's bots, but that's fine.
Okay.
They're gonna stay in, I think.
Okay.
Okay, they're gonna stay in. That's fine.
I don't know. Are they possible to kick out?
No, this is. Oh. Oh my god. Are you good?
What is that?
Oh jeez.
That was pretty dramatic.
I guess I got overrun by bots. I don't know.
That's one way to make the segment interesting. Oh my god.
Oh, now I'm watching it on the rewind on the YouTube live. Nice. Nice job.
We need to add a timestamp of like Risha's entire setup breaks at this point. Okay.
I should be there.
Yep, you are there. Václav, are you there as well? Does that work for you or no?
Yeah, sorry. I'm now trying to reply to one question in the chat. So maybe in 5-10 minutes.
That sounds fine. It's fine. Okay.
It's a big
question.
So
I mean, if everybody can, I can start the game again. It's gonna hopefully work. Yep, that sounds good. So maybe we take a bit of time to try to implement some more advanced robot, and like at least one that captures stuff, and then we can sort of see if that worked or not.
Yeah.
Oh, Basha connected again. Sounds good. Oh,
Oh,
Slavik.
does
Hello,
it
hello. There's more
disconnects
people
me? Okay.
connecting. Guys, link to final August. Okay, yeah. Nice, nice, nice. I'm gonna connect as well.
So should I code on my own then, or?
I think so. I think the best for me would be to just, I guess, keep this screen shared, and then, because right now I'm wondering how to do this. I guess I can program on the other side here, and I can just keep this shared.
Yeah, I don't know how you would like to do it now before we have stuff ready.
Maybe I can. Yeah, I'm wondering. Because right now I could also explain the more advanced bots, but you would kind of hear that, so that wouldn't make too much sense.
Yeah, maybe not. I mean, I can also say what I'm doing, sort of.
Like, yeah, maybe we can also just work on this collaboratively, because it kind of makes
No!
sense. No?
You mean to beat the bots? I want to beat Risha.
Okay.
Why?
Okay. Makes sense, makes sense. But the users can connect, so that's good.
Yeah.
Seems to work.
Okay, Vashek, so do we agree? Then do we agree not to read like the other bot implementations?
Yeah, sure.
Okay.
Yeah, I think maybe I'm just here as technical support, and maybe I'm gonna go into explaining the commands right now a bit more in depth, because it may be a bit like confusing, because the bot library includes some like basic functions, but I guess maybe listen to me if you care about the like particular bot commands like explained. Otherwise, I'm just gonna be yapping a bit, and then if you got some,
I'm
sorry?
going to try to listen with one ear.
Implementation question. If I have like two commands that are conflicting, which of them like gets passed on?
The server will probably crash, so please don't. No, I'm kidding. I'm kidding. So I think greedily, because the commands will all be sent, but when the server is evaluating what units it can send, it will do it in one step to try to see which commands are possible, and it will just nuke the others. So that this is undefined behavior. Like one of the commands will be I think that, like the first one should be executed. If you like send 3 units and then you send 3 units to a different one, then only and there's gonna be 0 units at the end, then it works. But if there's negative units, then the second command will just be dropped because it doesn't make sense. So like it will just greedily execute the commands based on if it can. And I'll just go over the stuff here, I think, because there is maybe some. I think it should be probably pretty self-explanatory, but just in case I'm gonna go through this. So just move creates a move command from to vertex and based on the units. So just make sure that you're sending the appropriate amount of units from one vertex to another. And maybe guys, this is important. You can create 2 commands from the same vertex. You can send like half here and half here. That's okay. You don't need to send all units. You can only send a partial amount of units. That's fine. You don't need to be sending only one command for each vertex. Okay, for the game objects, there's my vertices, enemy vertices, neutral vertices. These are used here. So for example, if you want to only get the maybe it's not used here, but if you have a particular we get neutral neighbors. Oh no, I guess this is like a top level function. So if you just iterate over enemy vertices, my vertices, neutral vertices, you can do that. That's fine. Vertices have these properties. I think these are again pretty self-explanatory. Where the weight stays constant, so each vertex in the graph has a particular weight, but the units are different because they change each round based on the commands that we send. Neighbors, again, neighbors for the vertex. I think that's sensible. Enemy neighbors, neutral neighbors, my neighbors. I don't think there's much to add here should be pretty self-explanatory. These things should ideally be relatively foolproof. So if you just send a vertex ID that doesn't exist or it's not yours or whatever, it should just return an empty list. So hopefully it shouldn't crash, but I didn't read all the implementations, so maybe don't push your luck. And yeah, these I think are the most important functions because they say, okay, if I can capture a vertex, so if I have enough units to send to a particular vertex to start controlling it, you need to check for this because otherwise you just send your units to die, which is like Then frontline vertices are those vertices that are adjacent to some vertices you don't control. And distance to frontline, that could also be useful for some of the more advanced bots. It just says how many units, or sorry, how many vertices until you get to the front line. So I think those are pretty self-explanatory, I would say. So maybe I'm just gonna go ahead and start. I can also
Sorry,
show the settings.
What is weight?
Yeah. So each vertex. Oh, somebody joined. Each vertex has a weight, which is like the amount of
Okay.
units you initially have to send to the neutral vertex to control it.
Okay.
So if it's weight 3, you have to send 3 units and then you control it. And
But isn't
then
it 1 in all of these?
no, so here it's 1 and 2 and 3, and so this
Oh,
graph
okay.
has min weight 1, max weight 3. I can set it to 1.
I guess it's just in mine.
Yeah,
That's weird. Mine has all ones. Yeah.
That's not weird. That's maybe just the default settings because you can, if you go to settings, you can change the graph, you can change the weights, you can do stuff.
So it says max 3, but maybe because no game is started? Like everything is set to 1. Like in yours? No. It's weird.
You can just go to settings now and you can change it if you want.
Yeah. Okay.
Yeah, so the weight of the vertex is just, it adds that many units each round to if you control it. So if you control very heavy vertices, it's going to spawn this many units for the particular vertex.
Okay. I see.
And I think I'm gonna maybe mess around with the settings here so you can change the different grid types. It also has a hexagonal grid, so you can play on a nice hexagonal pattern. Maybe I'm gonna join the default game so it can be played. So right now there is a player. So join. We are here. If you want to start, you can start. Otherwise, I'm just showing the settings. And
yeah. What? That's a crazy graph.
Yeah, it looks cooler, and you can also remove vertices. So if I say 0.1, then some vertices will get nuked. So it's a bit interesting to play.
Wow, funky. I mean, if you make a bot that takes that into account, then that's crazy.
Yeah, like there's a... Oh, this one looks particularly nice. I'm just gonna start the game. Show me what you got. Oh yeah, this bot is not good because like there is much room for improvement. This is not amazing. Oh, I lost so badly. Oh my god, Slavik. I need to improve my bot. Okay. Maybe I'm gonna share that in the meantime, or if you guys at some point have a bot that you want to test, let me know. Otherwise, I think I'm just gonna try to improve the bot. Maybe talk about.
I can show what I have now, but I don't. I mean, or maybe you can go to my room so that I don't have to change the default room.
Yeah, sure. What's the room ID?
Venza.
Oh, I can just do it here. Oh, okay, I can see the room.
Okay, so I'm trying to... How come the bots are doing something in the first round and I'm not? Invalid command or game not ready, I'm getting. So what I'm trying to do is like define a different strategy for the first few turns of the game.
So how do you determine the first few turns of the game?
Oh, right, I see. I'm sending some commands where units are 0.
So that would do it.
I guess that's, but does it also kill my other commands? Maybe. And this doesn't auto reload, right? I have to restart my script.
Right
Okay.
now it seems to work.
Boop. Oh, okay. Now we're talking. Yeah. Okay. Interesting.
Yeah.
So I'm defining a
oh.
I'm
Okay,
defining
so
a
what are you
strategy.
doing? Or do you
I'm
want to
defining a
explain that?
strategy for initial expansion. Like, as long as there are some neutral vertices left, then I'm trying, because the default strategy goes like all in and sends all the units there. So what I'm trying to do is, also this is super unfair based on where you start.
Yeah, the starting is a bit it's a bit random. By that a bit, I mean entirely.
Yeah.
I previously had it where you start at like the furthest points of the graph. I removed it, and now that I'm thinking, I don't know why I removed it. Because it would have been probably more fair.
Yeah. Oh, I'm getting destroyed here.
Yeah, the hard
Yeah,
bot is just rolling everybody.
Yeah, that's hard. Okay, so currently what my thing is doing works decently well. Oh, look, I've reached sort of an equilibrium. Oh yeah, I'm just chilling.
Nice. Yeah, but yeah, when it starts attacking, it's gonna be much better, but...
Yeah, then it destroys me. Hard
Cool,
bot.
cool.
So that's my
Looks nice.
Venta bot.
So the initial strategy is to like expand rapidly at the beginning and to try not to like attack people, I guess.
Yeah, I'm just expanding to neutrals.
Okay, makes sense.
And so this is what I got.
Nice. If you guys want to show something else at some point, then tell me. Otherwise, I'm maybe just gonna work on my bot a bit. But yeah. Let me
Risha?
see.
Not yet.
You're cooking something very spicy, I guess. Nice.
I'm picking up my supply lines.
Oh God. But okay, this feels kind of weird because I already implemented the like medium and the hard bot, so like I know exactly what I want to write, so it's a bit.
I mean, I can also, if you want, I can share my screen and show what I'm doing.
Sure. If you want, if you want to do that. In the meantime, sure. I think it might be good to maybe give it like a few more minutes for like 50 to see the bots, and then I can maybe have the showcase against like the medium and hard, so we don't spend so much time because this is gonna be otherwise like a long segment.
Yeah.
So we can go to Q&A. I think this is more like we can treat this as like an initial initialization. If people like see that this is interesting, they could maybe implement a bot later and just have it as like a teaser. I guess that makes more sense than like spend an hour here, you know.
So what can I do here? Game.get.
Okay, I'm gonna switch to your screen.
Get my neighbors? How can I get my vertices?
You can iterate through the my vertices array.
Okay. Is that a function? No.
It's a property.
Okay. So it's this type. It's like vertex is a vertex, I guess.
For some definition.
I'm just trying to get the
type hints.
Autocomplete here. Yeah.
It should be there. That's strange. It should be type hinted.
Get neighbors. Get all neighboring vertices for vertex.id.
So what's the retreat? What's the retreat strategy about?
I want to see if there's someone who could kill this vertex, and if so, then I'm going to run away, if possible.
That's very smart.
Let's see. So I'll get enemy neighbors of vertex.id. Oh, what? I'm writing JavaScript here. If neighbor dot, so it's already enemy units is greater than like vertex dot units, I guess, then like we're going to say there is danger. And now if there is danger, and if I have somewhere to run, get my neighbors. Okay. Vertex.id. Oh, I guess I just want to say I have my neighbors, and if I have at least one neighbor, then I'm going to just run to a random one. So commands that append game.move. What was it? Was it self.move? From vertex. So from vertex.
What do you want to do?
To move all. I'm going to escape my neighbors, and I can use randomness. Right? Including both endpoints. Rand range is what I want, I guess. And I'm going to stop at length of my neighbors. So I'm going to escape with all of my guys. And surely that's going to work.
You can. It's interesting. It's interesting because you can also do like the other way of like reinforcing a particular vertex. It's
okay,
like...
are we going to run away? Oh, I ran away.
Oh, okay.
But I'm just sort of running away and dying.
Yeah, but I mean, if you combine that with some, if you combine that with some like
oh, that's not
attack
bad,
strategy,
right?
yeah,
look at this.
like at least
I mean, I'm
like
still
you're
getting
gonna.
destroyed.
I mean, you are, because he's generating like 10,000 more vertices per, stuff, but
Because I don't have any attack commands right now, I guess. So the expand to neutrals one. Why do I only get neutral neighbors, right? I'm just gonna go get neighbors. And
yeah, you can just remove the. You don't need to do the neutral neighbors. You can just do like any. The easy bot is easy for a reason, so so it,
if n dot controller isn't what? Self dot id? Player id? Something like this? Okay, let's
Yeah, the API might not be production ready. Let me just say that much.
I probably shouldn't care about. Okay, I'm not attacking here. I should be able to attack, right?
Yeah, if you have more than units, if you have more units than that particular vertex, then yeah.
Oh yeah.
Risha has been cooking something devious. I can just see the concentration. It's gonna be like the biggest killbot ever.
Ooh. What is this? Why am I not? Something is going wrong. Oh my god, Risha, are you are you crashing?
Oh yeah, it's over. It's already over. It's already like 500 lines of like there's the Dijkstra that redirects the units from one front line to another. It's already, yeah, it's we're done.
We're cooked. I'm running away. Oh, I'm actually killing something.
Nice.
No, I'm still losing to the hard bot.
But still. Nice. Risha, do you wanna maybe, I think now it's 50, so maybe I can, if you have some ideas of how to do the robot, or like, sorry, how to do the bot or how to run it, maybe we can discuss that now, and then I can show the medium and hard bots, and we can go to Q&A.
Yeah, sure. Okay. I mean, I don't have any clever ideas, and this wasn't like enough time for me to. I'm slow.
Yeah, no, I'm sorry, there was no time. I'm sorry, but yeah.
Yeah, we also started late, right? But yeah, like
Yeah.
like I wanted to kind of send troops to the front line, like basically have like a supply chain of the guys that are kind of inside of the region that you control, to send them to the front line, and that's basically like all that I got. So not really anything smart.
Yeah, but that's pretty much the hard bot. So I mean, yeah, that makes sense. Like I can I guess show the implementation that I got for the medium and hard bot. I think that would make the most sense right now. So I'm gonna just close these things. Can you guys see it, or is it too small?
Sorry, I'm
Maybe now
playing
it's
around with
better.
the bot still.
Is it good? I will just assume that it is. Yeah, so the easy bot is just easy because it just expands the neutral vertices as I shown before. So that was the one that in the quick start. And the medium one is a bit more complicated, but still relatively simple in the sense that it expands to neutrals and it also moves stuff to the front lines. So as you said, Risha, it's the same idea of like first off, I want to expand to neutrals. So if I'm on the front line, that's the same function from the easy bot. I just want to go to the neutral neighbors and try to control them as much as possible. And then another strategy is that I move to frontline. So that means that for my vertices, if they're not on the front line, they just move to frontline. So I just explore the neighbors that are closer to the front line than I am, and I just send all the troops from inward outward. So that's that thing. And again here, weakest neighbor, and I'm just enforcing the weakest neighbor. There was some heuristics. So like this is sort of better, but it's still not like the front line is a reasonable measurement. But like if you have like a corner of the graph here, then the front line can also be sending the units the wrong way. So this is not like the ultimate strategy that you should probably be implementing.
Also, the front line is not like when you're neighboring to some enemies, but like
Yeah, exactly. So frontline is
Wait,
just
it's
like
not?
the border. No. It's frontline is the border of the graph, like of your controlled area. So it's not even like where you should ideally be reinforcing the unit. So this is like medium. And hard is just that it also attacks. So it attacks enemies that it can attack, and it tries to spend as little as units are necessary. So it just sends enemy units +1 if we can, and attacks the weakest neighbors. And yeah, that's pretty much it. So this hard bot just essentially tries to expand to neutrals for the frontline vertices if there are some neighbors that are neutral. Then it expands to the front line if it can, that for the interior vertices, and then it finally attacks the enemies that it can kill, yeah, from the front line. So it's hard in the sense that it like is not completely like inept. It can like do things, but there's so much room for improvement in the sense of like defining what a reasonable front line is and when it should kind of expand and stuff like that. That like there's just room for improvement. So I mean I can try to run this code again, I think, because I mean you kind of already, oh wait, I can't, never mind, you kind of already saw it. But if you go to the how can I play as I saw or as I shown, you can just take this and maybe you can take the easy bot or the hard bot or whatever. You can just run this code and you can expand and see if you can beat the easy hard bots. And if there is some interest from people playing this, then I can expand this to like more tournament style where it like generates the like many different pairings and stuff like that or whatever. But yeah, proof of concept pretty much. So it's interesting that we kind of converged on the same strategies that I was thinking about. So but yeah, I think there's much room for improvement.
I'm not sure if there's some kind of bug, or I feel like my strategy is not expanding when it should, and it's printing some commands. But there is the retreat thing, which the hard bot doesn't do, right?
Yeah, retreat, it doesn't do retreat. No, it doesn't do retreat. Because retreat effectively, I mean like you are retreating, but it depends on whether that's actually useful or not. It probably is. So it doesn't do
Yeah.
retreat.
Mm,
Yeah, so
it
that's
might
one
be
thing where it can be improved. Yeah.
maybe like safety is another thing. Like if you expand towards corners, you're probably in a better position than if you're in the center.
Yeah. Yeah, stuff like this where the like frontline is a good metric for like just general stuff like you want to expand, but not for like it doesn't account for the positions of other bots, so you are not really exploring the graph in a smart way where it's like you're not expanding to the defended yeah, to the defended vertices. So yeah, that makes sense. That makes sense. Cool.
I like the game.
Nice.
I
Do
just
you?
wish I had more time to fiddle with it, but maybe I'll do that
Yeah,
after
I
the
mean,
live stream.
yeah, we've been live streaming for how long now? 3 hours actually, exactly. So it's kind of
Those are
maybe we
rookie
can have a
numbers.
maybe we can have a dedicated tournament after or something.
Yeah, I'll be
Okay,
ready.
nice. Nice. I think we can go on to Q&A now. I'm gonna go back to the main screen, stop sharing. And is there somebody responsible for Q&A or are we just eyeballing it?
Arisha, would you like to have the honors since you haven't run the segment yet? Sorry,
Sure.
I'm putting you on the spot here. If you don't want to, it's also fine.
No,
Sure.
it's not.
No, it's fine. It's fine. Let me find the Slido link. Oh, it's actually in the live stream chat, right? Somewhere, the first message or something. Nice. Okay, so there are some questions. All right, so I guess we can just go from the top. Maybe I'll read the question and then whoever feels like answering can answer. So the most rated question is that in today's age, by doing software engineering, I feel like I wouldn't get to make much difference in this world. I guess it's not much of a question, but can someone can you guys comment on that a bit?
Is it like an AI doomer take, or is it
Kinda, I feel
a good
like.
take?
I mean, I feel like it's kind of all that we're doing, like all that you see around here, like from the setup of like the live stream and from the games that you saw and from the videos that we make, that's all software engineering, and there's quite a lot of it in terms of like creating the animations and this like stuff that goes into it. And I think it's helping people, so it's definitely something that you can do when you just if you like think it's a bit doomer take, but yeah, I think you can definitely make a difference.
I think like even more so.
I'm a bit confused from the question regarding like what other jobs like you would feel that you are not making difference, right? Because it feels that like you could feel kind of like a globally that like nothing makes sense, like nothing makes a difference, or you could feel that like software engineering in particular doesn't make a difference, and that seems like two different takes.
Oh, sorry, 1 second. I can share the screen because nobody's sharing it. But is there a way to kind of do it in like a presentation? Oh my God, present mode. Oh no, oh no. Oh, I fell into the trap. No, help.
What happened?
How do I get out? No. Okay. Sorry, go ahead, continue. I'm just gonna fiddle with this.
Okay.
Yeah, I guess there are like many. Sorry, go.
No, go.
No. After you.
Yeah, I feel like there's more and more you can do with software engineering. I mean, I sort of read it as I'm not sure if to read it like an AI take or like a societal take, but I feel like because technology is shaping a lot of things today, like software engineering is still super valuable. And then there's the question of like, is it now not worth getting into because you can like vibe code everything and you don't really need to code?
Yeah, but that's like I feel like if you vibe code, then like you just need to be careful in the sense of like what are you offloading? Because if you're offloading the interesting parts, the creative parts, then you're doing it wrong. Like obviously if you like want to just say I want to create this amazing app and you expect it to create an amazing app, yeah, that's a bad way. But if you offload the stuff that's like the bootstrapping part, like the learning the new framework part, but you already have something in mind, I feel like that's where it just like kind of supercharges you to do things that are like the interesting part of software engineering without having to like go through the mud of like learning this new framework and things like this. I think that's just a matter of how you're doing this. It's not like inherently wrong, vibe coding, but it's just a tool, and I think you just need to know how to use it.
Yeah, I think so. Although like there's the extrapolation into the future, well, where like it will be able to replace more and more of what you do. But I guess it still doesn't choose, like if we're using Polylog as an example, it won't like choose video ideas for you, choose what animations to make. Well, perhaps.
I mean, in the next 2 years, right? Or
No. I feel like these were the same arguments for like when people were like switching from assembly to like regular programming language, in a sense that it will like replace the job that people have to do in order for like. I think this is like a tune that has been like sung for quite a long time, and it always feels like now is different, but I think it's a bit too early to tell. I don't know. I'm not on the doomer side.
Yeah, I mean, I'm with you, but I think Vasek and Risha might have a different take.
They're already. No. Vashek's been happily vibe coding stuff. I don't know. He's on the bandwagon. No.
no, I mean, I'm totally like on the bandwagon. I'm also kind of like AI doomer in the sense that like Václav is talking about. Yeah, I mean, it's a very complicated question in some sense. Like trying to guess the future and trying to guess like what the capabilities are going to be in few years. Hard to say.
Yeah, I think
But,
we kind of.
Okay.
Sorry, go for it.
Maybe
No, I just wanted to say that.
For the next question.
Yes, I think we kind of strayed away from the point of the question, but I think we answered that as well. So.
Yep.
I actually enjoyed the like
Yes.
AI future of coding debate. I feel like we could go more into that later.
There is gonna be a flame war with tabs and spaces soon, so let's just but I don't know who controls the Slido, but you need to kind of
me.
click off the question.
Yeah, that's
I'm presenting
me, it. Okay, so now I have to mark that as resolved, right?
Yep, think so.
And I can read the next question. So the next question is, are you going to cover arguments in favor of and against P equals NP in one of your future videos?
Yeah.
So first,
I'm not sure if this is a plan for a future video, but like we can say something now, right?
Yeah, we can maybe do like a show of hands, like who thinks like P equals NP and who thinks it doesn't. So who thinks P? Sorry, go on.
Yeah, so I actually have like a hot take, but like the hot take is not that like P equal to NP, but like it's actually like possible. That would be like my hot take.
That's possible. So
sorry,
like,
what?
Yeah, so no, so I actually like so from time to time I am like procrastinating on manifold and I'm like betting on questions, and I think like recently I pushed the probability of P equals NP from like 8% to 9% or something like that. So,
that is the biggest
like
cope I have. Oh, that is a scolding hot take. That is.
I didn't know you could bet on that, but it makes sense. Yeah. You got really into prediction markets recently, right? Or recently, maybe not recently.
Like the last few years, yeah. It's like a way to burn time.
And money. Oh, but this is virtual, right? So it's different.
I mean, like you earn some money, but like less. I at least I am like earning less than like what I would earn in some like more reasonable ways.
But you are winning the bets.
That's the important part.
Sometimes, yeah.
Sometimes not.
Very modest
that's
answer.
Almost it's as almost as if how that works. No. Okay.
Anyway, I can say like one more hot take to the P versus NP question. So that's like my favorite quote from Ryan Williams, who is actually like the leading expert on complexity. And I actually found it in the paper. I can actually even share it, Tom. Let me actually share it. Can you see it?
Sharing it now.
Wait.
Can you see it now?
For all intents and purposes, yes.
Can you see it, Tom?
Yep.
Yep. Okay. Yeah. So this is the quote. Like, you know, intuitively and obviously, P is not equal to NP, but only intuitively and obviously.
I mean, true.
You know, it's like very intuitive and like very obvious that P doesn't equal to NP, but actually there's like not. It's only intuitive and obvious, like, you know, that there is no like like great theoretical justification or like, you know, something like really weird that P equal NP would imply, or, you know, something like that.
Yep.
And actually like Ryan Williams would give you like actually even like 80% probability that P doesn't equal to NP, or in other words, he would.
What, can you send a link to this paper?
So does he believe that the ZFC is consistent when he puts like the probability of false at 0?
Yeah, I guess this is like rounding error, like 0.00001 or something like that.
Okay.
Yeah,
so...
but you know, like this is like, on one hand, this is like a top guy in the community. On the other hand, he's like kind of famous for being like going a little bit against the current in some sense.
So what you're saying is 50-50.
Maybe one thing about covering this in the videos, less about P equals NP, but more about like polylog video topics. We always have a debate about why people watch polylog and what's good topics for videos, and there's sort of like, we never agreed on this, and I guess we never figured it out. Like, my take is more that people enjoy the videos because of this sort of like puzzle thing, and the bigger picture stuff is not as important, which is why I think the zero knowledge proofs video was great. Because
I just got randomly kicked out of the YouTube live stream, so I hope we're still live. It just randomly asked me for my Google password. Very nice, very nice. Thank you, YouTube. Thank you.
I guess we're good.
If we're still live, then good. But what is this?
Yeah, we're good. Yeah. So I mean, this sort of, here's like an interesting puzzle, and then coincidentally, it happens to be a useful topic for other things, versus like putting more emphasis on like theoretical computer science sort of essentials. Like, we had the video on the Turing Award with de-randomization, and we had one on what was it? The universal search, and then one more. Or am I wrong? Yeah, but then there's it's still not clear. But to me, P versus NP is a little too abstract unless we find some sort of like cute example or story to put there.
Yeah, it feels like it's been kind of debated and discussed for like, I mean, there's been so many videos that it's kind of hard to put something that's pretty unique to what we're doing and make like an interesting video. So I think it's like better for like the topics that we have right now. It feels like it's something that we can sort of produce in a way that's unique and that will like bring something. And it feels like doing a P versus NP is more like I don't know how to say it, you know what I mean, like mainstream / everybody does it / like it's like pop sci versus like something that's actually in depth.
I feel that there would not be like that much added value from like us doing it versus anybody else doing it.
Yeah. Okay, nice. Onward and upward.
Yeah, the next question is what's your favorite data structure and why is it a splay tree?
I wonder who put that question in. It seems like an undercover operative, huh?
I actually kind of agree. I don't know. I
agree. Interesting. Do tell.
Okay, elaborate. Maybe you can say what a splay tree is.
Yeah, this is awkward. I don't know what the splay tree is. I've heard about it, but I never looked at it.
Okay, so splay tree is kind of like a binary search tree, but instead of doing like some AVL like kind of rotations, you only basically always do like one kind of operation. Like whenever you do some stuff, whenever you like insert a new item or like delete an item from the binary search tree, you always kind of do the same rebalancing operation. That's called like splaying, and it's like arguably it's like, I wouldn't say way simpler, but it's like simpler than like AVL operations. And in some sense, it's like very magical because like splay trees do have like these kind of guarantees that like normal binary search trees have, but on top of that, like like they not only have like these worst case guarantees where you are like, okay, so like inserting a new item costs like log n time, but then magically if you kind of call it on the right kind of data, they can be like much faster than like log n. You basically like they're basically like adaptive in some sense, that like if the data that you call that you use them on is like there's like some pattern in the data, like splay trees will very often like kind of find this pattern and be faster than like the theoretical guarantee says that they should be.
Cool.
I'm not sure if I said this, I said it like in an understandable way. Maybe like Vasek can say something more.
You know, maybe it's like a topic for the next Polylog video. Who knows?
True. True. Nice.
I mean, it's a great data structure, definitely.
I thought we were doing a fast inverse square root next.
Oh, also we have some. Oh, sorry. We have some comment on the first one. It wasn't a doomer take. I'm going to uni next year. I've been passionate about computing all my life. I guess shouldn't have bored it. Yeah. I think we kind of get a sense from that. It's, I don't know. I think we're all passionate, and I think it's the most important part. Where like software engineering is just something where I just love the fact that I can think of something, and next day I just write code that does it, which is, I don't think, something that's in many professions. And like, yeah, if you look at engineering, that's certainly pretty close, but like the fact that I can just like type some magic words on the computer and make something appear is just, yeah. So definitely share the wonder there.
100%.
Okay, do you want to do next question?
Yeah, you don't want to share any other favorite data structures. Okay.
No, I need to cut you off because you would be talking about the split for like 2 more hours. I sense.
I think getting carried away is like, that should happen. I think that's the perfect.
That's true. But not about split. No, I'm kidding.
Okay, next question is, what are your favorite moments that happened during filming? For me, I think a funny moment was like when we were like filming this Polylog coin Polylog coin thing, and we have like about 20 takes. Like we like, I think everyone did a take.
Yeah, I remember.
I actually remember that like Richard created some kind of like meme with like me trying to do faces. Because you know, for me it was like pretty much the only video that I kind of like start in. I'm not really like the master of voice acting and like, you know, putting your face into positions so that it looks good on video.
Oh wait, I can find the meme actually.
It's in the outro, no?
No, you mean the different one, no? Like the.
Oh yeah, I can show you the screen if you got it.
Yeah. It was like the boyfriend and girlfriend meme.
Yeah. I'm not sure if you are comfortable with like sharing it
Oh,
with the
totally,
audience.
yeah.
Yeah, I'm
You know,
not, I'm not in
that
it,
boat
so.
has passed. that boat has sailed away. You know, like with the with the original video. So.
But it's in the outro, so I think it's pretty like the outtakes should be more included. I feel like.
Yeah.
Yeah, maybe we should do it more. Yeah.
Nice. But yeah, if you got it, I think. I mean, I was only in the last video, so for me not so much. But
Yeah.
there's some good outtakes. I feel like.
Yeah, it's also that for the earlier videos, like filming is very much an asynchronous process where it's mostly like we work on the animations and maybe we have a few meetings to discuss like how to do things or sessions to work on it together to be motivated. But then when it comes down to recording the voiceover, like before we did the faces or even now, it's mostly like me sitting in my room and then recording myself because like other people don't really have much to do there. And only when we filmed the last video for was it the zero knowledge proof one? Yes. Where we did at ETH, where we actually had like professional cameras and equipment. There was more of us, and it's fun to have more people in the room. But I also realized that a lot of it is just me saying the same thing over and over and over. So I'm like, it's not that interesting for anyone else to be in that room.
There's like one outtake of the last video where I keep repeating something and I just keep messing it up, but I don't think I have it right now. But that was yeah, talking to a camera is hard.
Yeah. This is a punch card sorter from the 1960s.
No. Yeah, it's just so hard because I usually talk like twice as fast as I would like to talk, like where I should talk in the video. So it's like, this is a punch card sorter from the 90s. It's like, what?
Yeah, it's can be really frustrating when you're saying the same thing for the 10th time.
But it's not like frustrating, but your brain just melts and you just keep like you just say like it gets worse and worse. I feel like there's like a peak of like it gets better and better, and when you hit this and it's not good enough, then you're done because then it just gets
Yeah.
worse and worse. And it's like this is a sorter from the punch cards. Oh, you know. So it's like
near Germany, Frankfurt, right?
Yeah.
Yeah.
But that was something I said, right? That was just.
But you know, actually speaking of punch cards, this has actually been like one of my favorite moments.
Oh
of,
yes.
Like, polylog filming. Like
yeah,
you know,
that was
just
awesome.
Like going to the museum and like you know, Roland like was there like super enthusiastic,
Was,
like
yes.
giving us like a private tour through the museum. And then like you know when the button is pressed and like the machine starts actually doing something and like the cards end up in the 10 buckets. This is pure magic.
Yeah, and not,
cool.
like I feel like it was also so stark compared to, like, if I remember correctly, the first people we were reaching out to was like was it NTK, right? Or was it? Yeah, and like the difference,
was like a huge contrast.
Yeah, the difference between like that of like, okay, you can just like send us some money and we like show the non-functioning thing versus like this random guy in Germany just like, oh, look at this machine, it just works, just starts it, just sorts the punch. I was like, what? That's crazy. It's so like just the insane contrast of like, oh yeah, by the way, these machines are like older than your grandparents and they just work. We just made them work. And he's like they're off in the corner working on like some old memory with the heater because otherwise it wouldn't. It's like just the most metal thing. Just incredible, absolutely like amazing.
Yeah.
So I think favorite is Ron.
For sure.
Nice.
All right. Next question. Maybe a hard question. I don't know. What are your future plans for the channel? Do you have any thoughts on the topics and frequency as it grows? I love your videos and unique style. Thanks a lot. I'm not sure who's the most qualified to answer this.
We can take turns.
Like for example, like for me, I would really try to experiment more with things like this live stream, like things that kind of are like you know less work. you know, like currently, like to make one video, we just need to spend like a few months because we all have our jobs, and you know, we are kind of doing it over weekends and over evenings and so on. So it just takes some time to create a new video, and I feel that like we have like more to say than 3 videos per year, and it would be nice to find some way of making it happen.
It's difficult because, again, the question of why do people watch Polylog, and whether the animations being very high effort is part of it. And I think to some extent it is. Like, I don't know, like 3 Blue 1 Brown, what was impressive to me when I started watching it, you know, like years ago, was also the quality of the animations. And I'm sure that that's part of the reason why people watch Polylog, but maybe now it's like more common that people have this sort of like quality of animations and put the time in.
I don't think you can skip that. Like it's I think if like it's not about like having a framework for making nice animations, it's about like putting the time to make them. Because like the frameworks are getting better, but that just kind of like maybe pushes the baseline. And if you want to actually make it nice, then you just have to spend the time and like be reasonably good, I feel like. I don't think it's like a cheat code to like make good videos to like have a better framework, I think.
Also, it's not just animations, right? Also, like one thing that like, you know, if you are a viewer, maybe you don't appreciate that like there are like, you know, 20 rewritings of the same script. And like this is just like something that takes time, and it like takes input from other people, right? Like usually it starts by like me writing something, and then like few rewritings later, I just like don't recognize it anymore. It's just like it's the script is kind of like moving in some direction, and like maybe if we were like amazing script writers, maybe we would need just like, you know, 3 rewritings. Maybe Grant has just 3 rewritings, I don't know, but like in our case, I think that like 10 rewritings at least are just like low bound on what's needed, unfortunately.
Yep. Yep, makes sense.
And that, okay, yeah, that's like harder to automate away. But I think that one is a bit different because it's less sort of raw time. It's like, I feel like it spend less time on it, but maybe like more intense thinking time. Like with the animations, it's more like you just have to do it, you know, and you are going to spend like a week on it, each of us, every time. And I don't know, or
it's
maybe
like
I'm being
architecture
naive about
design
this,
versus implementation type of thing.
Yeah.
Yep, agreed. And also we're launching a crypto coin soon, so that's another.
Oh, that's true, yeah. But I feel like I want to make the crappiest thing possible in a way. Like with this, like making sort of like if it's not the important part, then don't bother with it and don't be perfectionist. But I think with Polylog it might be too late. We're already in this like high effort animation land, and there's no way we're going away. But
we can always make it worse. You know.
Yeah.
Just outsource to like the new video models of like just make a nice fucking math animation or something. Just make that, and you know.
Yeah. One day.
Yeah.
By the way, speaking of experiments, I always like we always say like, oh, we do that for like experimentation purposes or like for exploration. And I really like it, and I feel like most of the time we are just like, oh, is this thing gonna be good or is it gonna be shit? And then we are always like, whatever, it's like exploration. Like we need to explore more. Yeah, so maybe at some point we could do a monologue or dialogue or whatever, which is just like Vasek talking in front of a blackboard. I don't know.
But like literally because of the name, I don't like. It doesn't need to be good, but monologue is just it's just.
That's very good. Yeah.
And then we just make the final video with just epilogue, and then it's just like the circle completes, and it's just
the first video on the new channel will be prologue.
There is much room for shenanigans like that, I think.
It's just going to be a lifestyle vlog.
vlog. Yeah. Anyway, next question.
Actually, I'm not sure if you know it, but like polylog, this is like, you know, if you spell it as like Poly and then Logue, I think, it is like dialogue, right? Like dialogue or monologue. Like monologue is of one people, dialogue of two people, and polylogue is like several people like talking with each other.
Ooh.
So
Well, that's
actually, there is
fitting.
some kind of like depth behind our name.
So, and is that depth because of randomness or because of thought?
So yeah, actually, like, you know, the real story behind the name is that like me and Vasek just wanted to have like a short name, right?
I mean, yeah, but it's like, yeah, sorry.
Yeah. And like we had a lot of bad ideas. Like, you know, one of my bad ideas was like busy beavers or something like that. That was not that was not my brightest
Oh
idea.
my
It actually turns out that this is like some kind of kids channel with like, I don't know, like billion subscribers or something like that. It's called Busy Beavers. So that one was taken. Okay.
Clearly a very good name though.
And then, like, you know, polylog. So we were at ETH, right? And ETH is like Polytechnique. So everything at ETH is like poly something, like polyball, polyterrace, polymensa, and so on.
Polyban.
So like, you know, we had like this polylog, and it's also like just like a cool name from theoretical computer science.
Mm-hmm. Makes sense. Makes sense.
And also log means to know and poly means to many. So I guess Vasek knows a lot of things or something like that.
That's deep.
Yeah, I guess next question. Are you planning to make a video about SAT solvers?
No.
No. Next question.
I mean, yeah.
I also feel like we don't have anything interesting to say there, I guess.
I guess.
Yeah.
Maybe because we don't know, or
I mean, there is actually some. I feel that there's like some cool theory behind it. Like you could, for example, talk about some kind of SAT solvers that solve, like, for example, if you have like 3 SAT, right? Then like you can actually, I think, solve it in time like 2 to the like 0.9 times n or something like that. Like, you know, you can do some like non-trivial stuff there, I think. But yeah, I right now I'm sure if we have a good plan, like what to cover there.
It's also
maybe if something like falls into maybe there's something that's pretty interesting that we could like cover in some unique way, then yeah, but like again feels like one of the topics that's been like pretty extensively covered. I don't know.
I don't really know much about SAT solvers, but I imagine it's more like heuristic based, and because it's an MP problem, there's no like good algorithm, and polylog videos typically have a structure of we're going to show you this algorithm and prove that it's fast. I guess there's always a proof aspect to what we do, and we don't really do heuristic algorithms. So it might be sort of out of scope and like too practical for polylog.
Makes sense.
Although it's experimentation, you know.
Exploration. Let's go.
Yeah.
Okay, next question. I consider AI a new programming paradigm, like imperative/functional. It is differentiable programming, inducing a probabilistic distribution over the program/output. Thoughts?
It feels like pair programming at this point.
I'm not sure if I get the question, like, kind of not...
Yeah, I mean, I kind of agree with the question that I also feel about it, like some kind of like new paradigm of like how to code. But I feel it's like more high level than imperative/function. In some sense, like for example, when I'm vibe coding, I sometimes don't even know like which language I'm vibe coding in. So it's not even like imperative slash functional. It's just like,
Okay,
Claude
Vashik
tells me
really is
that
discovering new paradigms.
like, Claude kept like telling me something about like React, and then I learned that it's like the actual language that it's being written in, right? And like, this is like way above like imperative slash functional, right? It's like
This is way above programming. This is art at this point. This is no longer.
Modern art.
But I mean, there is Karpathy's pinned tweet as the hottest new programming language is English, which is kind of true.
True.
I think it's like not like you can still apply. Yeah, I don't know. Is it declarative or like imperative?
It's not. I don't think it's a paradigm. I think it's just like you have an like an intern who has infinite knowledge but is kind of dumb for some things, so you just need to watch over it and talk to it because you're kind of like managing it feels like you're not doing the programming anymore, but you're like at the management step where you're like looking over what somebody's writing, like looking at the code, does it make sense, just directing it. And so like it may be the paradigm might be imperative, functional, whatever, but it's more like pair programming or like management slash like giving instructions instead of just writing the code yourself.
I suppose.
Actually, what you said about like or like I think it's kind of a different thing in the sense that when you program normally you have like a source code and that's like static, and then you take it and generate like some binary and that's like gonna be different all the time, but like you keep the source code basically, and like the program is guaranteed to do the same thing all the time. And I think it like it would be kind of funny to have like a source code that's just English, and every time you basically run, when you want to run it, you run your LLM again, and you're like, oh, I hope this time it like produces it works.
actually, I feel that like something like of this type is going to be future, that like you will have like some kind of functions that will be like, do this combinatorial thing, like, retrieve stuff from database or something like that. And you will also have functions which will be like run agent on this document and output a string, which is like a summary of it. That like the code will be some kind of combination of like some kind of combinatorial stuff and some kind of like run agent stuff. So that like code will definitely be more probabilistic and like more like fuzzy and involve, running agents.
I think that's a little different than what Risha is saying, no? Because you're talking about like running LLMs as part of the code, and what Risha is saying, like doing program synthesis and then running the synthesized programs, right?
I see. Okay,
like,
that's fair point.
I think actually I saw. Sorry.
No, go ahead.
I think I saw like a joke Python package. That's basically like you have an object and you can call like methods on it, and the methods are like in English. And basically, when the method doesn't exist, like it basically like calls an LLM to like implement it.
Oh, so, I love that.
So you have like object dot like increment by 2. And then it like increments the number by 2 or something, and you kind of hope that it does the right thing.
Do you have have a link to that?
I'll try to find it.
Like right now you say that and it feels like a joke, but that feels like the direction like we're heading. So right now we're laughing, but eventually, I don't know.
I mean, I talked to a startup that is doing something like this, where it's like specification-based programming, like, and that's sort of what we're seeing with the vibe coding tools to some extent, but it's a pretty radical vision of like, you just write text files that describe what it's supposed to do, and then under the hood, the code can be in like whatever language, and then you can regenerate it and update it automatically to like patch security vulnerabilities, and you only look at, and then you can define some tests, or maybe the tests are also sort of auto-generated to verify that the code is working. It's more a question of like how to scale that and how these components would interact. But
I mean, it's also like where at the inflection point of like this new technology are we? Because if we're like leveling out, then this is just pure like hopes and dreams. But if we're like in the middle, then I would definitely see something like just your code base being like a description of what it should do. And I need to generate the code, like Go code base now, so just do that. I need to generate like an Android native app, just do that. But yeah, I think it really depends on like how much more you can squeeze out of the current approach. And that's something that feels quite impossible to estimate at this point, because if you look at like the past like 3 years or even like 2 years of development, yeah, it's just like I don't think anybody knows besides like the people who are kind of leading the LM field.
I mean, I guess the sort of default opinion now is that it's plateauing out, right? With like the GPT-5 release being sort of underwhelming or like not big improvements. Vasek is being like,
Yeah. Yeah,
I don't really feel like it's plateauing. I feel it's more like sure, GPT-5 was like incremental upgrade, but like we have had like a lot of incremental upgrades this year, right?
Yeah.
If you compare GPT-5 to like GPT-4, like when it started, like, you know, the first GPT-4, it's actually a huge upgrade. So I think if you are looking at some of these graphs, like, you know, that are trying to measure capabilities, I don't really feel that there is any plateau. It's more like actually going faster and faster.
Interesting. We
But
can
that,
also
I
bet
mean,
on the
we will
play
see.
market on
We will
that.
see in half a year, I guess.
I don't
Yeah,
think
exactly.
so.
Sounds good.
Because like I think the consensus is sort of like we've squeezed out most of what we can with pre-training, and things are now improving with fine-tuning data, which is a lot more costly and doesn't just sort of scale for free with compute. And they're doing like inference time optimizations, right? The reasoning models. And it's no longer like, oh, if we throw 10 times the compute and 10 times the data, it's gonna get 10 times, not 10 times better, but it's gonna get better.
Yeah, maybe. I mean, all I'm saying is that, like, you know, if you look at like the final graph of like, you know, how capabilities are growing in the last 5 years, and you are kind of like abstracting over like where do the improvements happen, then like there I claim that you will not see any plateau.
Interesting.
Yeah. Maybe we can take like one more question.
Oh, well, we have like 4 more, so I would maybe just go through them all but faster.
Yeah.
Okay.
Yeah, that's that.
Ooh.
Yeah, have you considered creating a tutorial video on how to make videos with motion canvas? I guess Tom, now it's your time to shine.
I mean, so we don't have videos, but we have some blog posts that I guess we can maybe link afterwards, where I mean the switch was for the last video because Manim just sucks, and we were like, let's try something new, and I think we're kind of glad that we did, I would say, maybe because the feedback loop of changing something and not having to wait for FFmpeg to compile everything is like just 1,000 times better. But maybe a dedicated video, I don't know. I think the blog posts for this kind of like seeing the code and running a video are better because you can just read it and you can just copy paste the code instead of like having a video. Because I don't know, for programming I feel like this is more valuable. But I think we can definitely link this because I'm not sure if people even know about this. So
yeah, I sent the link.
Yeah, makes sense. Okay. Maybe next one.
I saw a number file video featuring Professor Avi, who mentioned that every math theorem can be reduced to the 3-graph problem. Could you make a video about it? So if I understand it correctly, that's exactly what we did, right? That's like the graph crawling problem, or no?
Yeah, I mean, like we have had like this P versus NP video, or like NP completeness video, where we kind of like hinted at like some aspects of this. We also had like this zero knowledge proof video, where we kind of hinted at some aspects of this. Like we never had like a video where we would like, you know, spend 2 hours like doing the reduction from math theorem to free coloring very precisely. But we kind of tried to hint at the important ideas in like 2 times 20 minutes, right, or something like that. So I don't think like we are going to return to this topic again with like third video that would like just hint at some aspects of this. I mean, in some early scripts of the previous videos, we actually wanted to go a little bit deeper, or like I personally wanted to go a little bit deeper and like show how to convert proofs or like something. But I'm actually very glad that we didn't do it, that we didn't go technical, and we stayed within like 20 minutes and some like reasonable stuff.
I think that's a pattern for all the script writing where you sort of write an extra page that gets nuked because it's like deviling the details, because we kind of have to rein you in terms of like what we can even, you know. But
Classic.
it's not it's I think yeah, it's nice that there's stuff like this because yeah, it's just
Yeah.
interesting.
Maybe
Yeah,
there's
and then
some...
also like my scripts always includes phrase like, you know, researchers in 80s did that or did this, which actually brings us to the next question.
True.
Yeah.
Yeah. What? Okay, I haven't seen this question. It's interesting. Have you considered looking into the algorithms of elevators? They are largely unchanged since the 80s, and I use it as an interview question for new developers. Nice. I like this question.
I actually know absolutely nothing about the algorithms of elevators.
Same.
So like, you know, if you can share something in YouTube comments, like I would gladly look at some links or something.
It's like you have... Yeah,
So
okay,
what's-
maybe let's not get into it, I guess. Starting to think about
I mean,
the
that could be
formulations.
cool. Are there any videos on this? I mean, yeah, we can move that later, but that sounds fun. All
Yeah,
the
it
science
sounds like
behind
a cool
elevators,
rabbit
there is
hole.
some videos. Okay,
Elevator algorithm. No, that's something else.
interesting.
Ah,
There's a spanning tree video.
spanning tree. Okay, maybe let's do the
Yep,
research later.
implementation details.
Yeah, there's a very important question for
The-
as the last one. Václav, I'm a new subscriber, and I have been watching some of the videos. It seems like you have a different haircut for each video. Is that an intentional choice?
Somewhat. I mean, it's always like having my hair forward, but then the level of like how much is it a bowl haircut changes with time. And I have the video on my own channel where I had a pretty intense bowl haircut at the time. And so at some point, my friend Frida was making fun of me and looking through the YouTube comments, and you search for hair, and there's like 20 comments, and everyone is bullying me for my bowl haircut. So that's
Yes,
another part of...
is there a reason for the horrible haircut, or is it just like a stylistic choice? What is?
Yeah, exactly. It's a bold haircut, a bold bowl haircut. Yeah, I
I
stand
don't really
by my
have much to
choices.
say with my haircut, so I'm just gonna maybe keep quiet for now. But
Yeah. Don't bash the bowl.
True.
Yeah, but I think now it does look a little bit more tame.
Cool. With the most important question was answered, so I think we're good.
Yeah.
Should be fine.
Okay.
But you do always like wear some like album like Black Country New Road t-shirts, no? Or
I
like...
try to wear different stuff each time to spice it up, I suppose.
I think... Wait, you stopped the sharing. Oh, nice. Good.
Yeah, I did. We're back in the main view now. And yeah, I think we're at kind of the end. It's almost 11. We've been streaming for like 4 hours now, maybe over a little
4
bit.
hours, yeah.
Yeah, and I enjoyed it.
That was nice. Surprisingly, things didn't break so much.
Yeah, I'm glad we did this. I'll have to return to the bot thing. Thanks to everyone who joined. We had a lot of fun. I hope you did as well or learned something, asked questions, tried out the bot. Yeah, we did a lot of things. So hopefully at least some of it was interesting to some people. And now that we're live streaming experts, I think we'll be back with more at some point. 256k subscribers.
7 p.m. tomorrow we go. No, okay, I'm good. Some other milestone. Wonderful. All right. Yeah. Thanks so much, guys.
Okay.
It was great. And yeah.
Thanks a lot.
See you next time.
See you in the next video.
See you in the next video.
Peace.
Mic drop.
I don't know.
Alright.
How do you do the outros? I don't have an outro screen. Okay, we just end the stream.
I'm just going to hang up.